All right. Can people hear me? I've never streamed from this computer, so I have no idea if this is gonna work or not at all. Um, let's see. And then it looks like there's a huge delay on the YouTube stream, but that's fine. It's not really an interactive stream, so that should work just okay. But can't see the screen. Like you can't see the screen. You mean you can't like no video? Yeah, the font is very small. Okay, yeah. That's fine. We'll try and up the font. What's a good way to do that in Xterm? Font size. Xterm font size. Let's see. FS. Let's see if this works. This is gonna be okay. So this will be FG green, FG gray, BG black. Okay. And we'll call this echo start term.sh. Okay. Yeah, sorry, I just had a really small font for this. So hopefully I remember to keep opening these terminals. Just ping me if for some reason I accidentally bring up a small resolution or low resolution video. Okay, so today we're going to be looking at a Bluetooth chipset, and I actually don't really know the specs or anything that we're going to be getting into. We're just going to kind of dive right in from the very start. I have done work on this chipset before in terms of writing some code that allows me to dump it off of the device that I'm working with, but I've never actually done much work with it. So let's see if I have ADB. I do. And I'm going to need to get the firmware. So the device we're going to be looking at today is a CI20, which is it's a MIPS Android device. It just happens to be the easiest Android device I have to dev. You're able to very easily just like flash firmware on it. It's just on an SD card, so if you make a mistake, you can easily just reflash it. You don't have to do fast boot or anything crazy. Like I can just toss around an SD card on my desk, which is really convenient. So first I'm going to get some of the firmware. I've got some custom builds of the firmware that I use, but let's see if I can just get a stock one, and then if people want to follow along in the future, or people watching this video, we should hopefully be able to do that. And I just have to find where they put the firmware here. Let's see, where do they put it? They see 20 images. Okay, so yeah, it looks like they have pretty late versions. So for the SD card, it's just this Oreo image. Oreo is a little bit out of date. This image is technically like 6 months old, but we're not looking at Android, so we really don't care. I can't imagine the chipset has changed enough that it matters. So looks like their mirror is a little bit slow. Hopefully this download speed picks up a bit, but if it doesn't, that's fine. We'll find something to do. So first I'm going to kind of set up the environment that I'm used to. I usually make a new folder for any new project I start. Pretty standard stuff. Once we have the firmware, I'm going to make sure there are plenty of copies of that around so that I can make sure that that is all sane. Did this download freeze? Come on. What keyboard do I use? I use a DOS keyboard. I've had this keyboard for a long time, and I just keep rebuying them or not rebuying them because they're breaking, but rebuying them because I've just never had an issue. I like the standard layout. Let's see, I don't know why that broke. And if we can't get this download to work, then I'll be able to actually use an image that I have downloaded previously. But this will be nice to kind of archive this image, get it all up to date. I don't think I've done Oreo on this device yet, that from an official image. So we'll just grab that now. What is the name of this file? In Android. Oops. All right. Is this font readable for everyone? I know I'm streaming kind of a weird resolution. I'm streaming at 1200p. So I don't know how that shows up in YouTube, but hopefully it's pretty usable. So once this is done extracting, I think I have BinDiff installed, and that's always well, we're not actually looking at this image in this case, so I don't even care. And then let's see, I have mounted a device. I'm just going to, up here on another screen, I'm just going to quickly flash this to an SD card. So nothing crazy, I'm just going to DD it over. dmessage, SD card is at SDC1, DDIF equals home pleb, Bluetooth reversing, Android Oreo.image, OF equals dev SDC, yeah, and I know you guys can't see this, I'm just DDing it over, but, so, we're just waiting for that DD. So, once this finishes, it is flashing. I maybe should have set block size. So, oh, you guys can't see the rest of the command because it's cut off. Oops. But I'm writing it to SDC, which is the little USB SD card converter I have here. They are cherry blues. I could maybe angle my microphone to try and reduce the amount of keyboard you guys hear. Sorry about that. All right. But yeah, very, very cherry, very, very blue, very MX. So, we're just waiting for that to DD. The device we're looking at, we can just pull up some images that it's a CI20. It's kind of a cool little MIPS dev board. It actually has a lot of bugs where the processor like kind of freezes up, so we might have to reset it as we're doing stuff randomly. But this is the one that I have, the version 2. It's got a couple like JTAG headers and stuff. It's got a couple USB host ports, and then a USB port that can be used as a device. So I actually have a cord that just plugs in this mini USB port, and this is actually what I grab ADB off of, which is pretty cool. So DD, not PV. I've never heard of PV. What is PV? Let me see. I'm gonna cancel that DD. Come on. Let's set the block size higher. BS is 1 meg. Okay. Yeah, what is PV? That sounds interesting. PV Linux tool? PV monitor. Oh, PV allows you to just view the progress, I'm guessing, or something. That'd be kind of nice. Pipe view, it's like with the progress bar. Oh, that's really cool. I've never used it before. Ooh, fancy. Okay. Huh. I'll have to try that out. I don't think I have it installed. So I'm guessing this image DD will be done by the time I would have it installed, but I will try to remember to use it next time. Okay, so we have this image here. And once that finishes, we'll boot up the device in SD card mode. Let me actually make sure I have this device around. It's sitting kind of behind me. So, and we're going to need 2 USB ports for it. But let's see, where can I set that I won't get shorted out? Okay, so we have this guy. Millennials and instant gratification. See, the real people use FreeBSD, and on FreeBSD you can do Control-T, and that will give you a status print on basically any command line tool. It's fantastic. Like, I don't know why that isn't something, the SIG info is not a thing on other, like Linux and stuff. There's probably some reason for that. So I think I have everything kind of set up here. I'm just waiting for that DD. I think I actually have this hooked up through USB 2.0, and how big is this image? 3.4 gigs, so that'll take 3,400 divided by, we'll just spin up Python. 3,400 divided by, what, probably 20 megs per second? Probably take like 2 or 3 minutes. Make sure it's only listening on localhost if you plan on putting it in debug mode. I like to live on the edge. I'm surprised your USB drivers work with Linux. I think that's why I'm not using USB 3, is because I don't think they are working. Or I think my card or something that I have in this box is not working. But, yeah, I'm not sure. But, I mean, we'll see if the DD completes. It's flashing on my SD card thing. Oh, there it went. 22.6 megs per second, 159 seconds. Okay. Do a couple syncs and switch this over. And hopefully this boots. I actually have no console or display output on this, so it's just going to be kind of cross your fingers that this device comes online. And if it doesn't, then I actually have 3 of these boards, so if one of them is not working, I can just grab more. So we have a light, and I think I have a serial port as well. What's a good way to do this? I can do screen, maybe, what is that? ls dev tty s0? Oh, it didn't like that. TTY-S1. I don't know which thing this is on, but I think we're good. Please, 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 please work. Oh, we're in. Nice. Look at that. Okay. So I do have serial ports for Linux, so I would be able to get like a live D-message output if I absolutely need it. But in this case, I don't think we need it. But we're able to see kind of all the boot logs here. I think I have enough scroll back, hopefully. I don't use tmux or anything, maybe not. Anyways, so we have this device here, and let's see if we can quickly grep for Bluetooth. So this is kind of what we have going on here. We have the standard Bluetooth stack in Android connecting to the Bluetooth port on this device. So what I'm gonna want to do, I want to use that command. Sorry, I know the terminal's small. Where am I going? I'm going to Bluetooth. Okay. You can demessage -u. Yeah. So we have this going, which is good. And over here, I'm going to grab some existing work that I have. I think it's, I'm going to do this off screen quickly. Not biggie. When did I do this? Reversing? No, not reversing. Jeez, where would I have this? I know I saw it earlier. Oh, there we go. Probably this. CPR this into CP that into here. Okay. So I have a couple tools here that allow me to get the Bluetooth off of here. Let's see what is in this file. Let's check this off screen again. Okay. So these are a bunch of memory dumps of the Bluetooth device that we'll go into and figure out how this works, because I forgot. This is some stuff I did about 2 years ago, but we have like the kind of firmwares here. So there's a firmware on the device that we can also look at, but I am particularly interested in the actual image from the running firmware itself, because that will get me a little bit more than you traditionally get. So I think the firmware, is it at system? Oops. See if I can find Bluetooth here. I might be able to Bluetooth BT stack. I don't know. I'm looking for the path to the Bluetooth firmware. Oh, let's stop. Here, we'll do this. I don't know how slow this device is for accessing these files. That's not what I want. Bluetooth prop. Yeah, I forget where they put this. Bluetooth parameters, Bluetooth APK, it's not that. Hardware, Bluetooth default, that's the actual like Bluetooth native code. Oof, where would this be at? System X Bluetooth cat star. There we go, CDX firmware. So it looks like what we're going to be looking at today is a BCM 4330, which is a pretty common chipset. I think it's used, I mean, this is probably a little bit dated at this point, but I think most chipsets are, I think a lot of chipsets are, or I think a lot of phones use this chipset or very, very, very close. So I think this is a combination chip by Broadcom, which is both a Wi-Fi chip and a Bluetooth chip, but the two stacks I think are completely different. I think they have multiple processors or something. So we'll take a look and we'll grab this firmware. If this is the firmware here, that might be a folder. So yep, there we go. And then if we line that up with this, it's saying the firmware file name is this HCD here. So we'll just grab this HCD image and make sure firmware, let's see, unloaded firmware. Does this run HMD RTE? Yeah. So I'm not sure. I'm not familiar at all with Bluetooth. I have like no idea what any of this stuff is. So let's see. We got the ADB pull act firmware BCM 4330 and BCM 4330.hcd. Okay, so that is the firmware image. That is directly from the, that's what's going to be loaded. I don't know if they give a load address or anything in these files. Let's take a quick look if that's an option. Product ID, vendor did to primary record. I don't see anything of that sort. So we know that the Bluetooth controller is at dev ttys2, and that will be something that will be relevant in a little bit. So, okay, so we have this firmware image. Let's get Ghidra up and running. I know this is not gonna work until I have a GIST. This guy. On DWM, Swing has some issues, so I have to use non-parenting, which I just found out yesterday. I've been wondering like why no Java works on this computer. So, and I think we can just and exit that. All right. So we can put this into floating mode as well. I don't know how hard this is going to be to manage on one window, but let's see here. I'm going to do, what do I want? I don't know what kind of things I have here. How do I set up these projects? Make a new project, non-shared project, Moose, project name. Let's actually give it a reasonable name. I don't know why I name things such stupid names. I'm trying to see what this is here. Let's see. Where did I put this? Sorry, I know this is off screen. I'm just trying to figure out where I put these things. So we'll make a Ghidra folder for this. Select project directory. Is that not loading? Oh, Ghidra's freezing up. I haven't really tried it on Linux at all, so I don't know how this is going to behave. I just like got it to work and just grabbed some random firmware online. But why is it freezing up? Oh, maybe that, I think the folder needs to exist. I did make that folder. Why is that not? Oh, this happened last time. On this window manager, I get pop-ups that go under. And I always forget that they're there, so things like freeze up. So let's see if this works. Oh, sorry. Import file. I was looking at like some D-Link routers and stuff. I've got the Pick of Destiny apparently. Let's see. We want to look at, what did we drop? Where did we download that? Bluetooth reversing. We named it. Didn't we just check that out? Oh, we put in unloaded firmware. Sorry, my bad. So I have no idea where I put this file at. Or I have no idea what, I think this is a MIPS, or sorry, not MIPS. This is an ARM. Ooh, I don't know if it's little or big endian, but I guess we're just gonna see what happens here. But let's go here, and, oh, okay. So let's see if this works for ARM little endian, and if it doesn't, I think this chipset might only be, this might exclusively be the thumb mode. So we'll see if this picks up a lot of instructions or not, and doesn't look like it did. So this looks like we probably have the endianness wrong here. Let's try and close that. Don't save. And I think we have to remove this and reopen it. But that doesn't delete it off the drive, if I'm not mistaken. Let's try ARM V5 big endian, maybe? That's what we tried little in last time. And I don't know where it's based at, so I'm just loading it at base address 0 for now. And then that goes behind again. And here we go. All right. I always forget I have to click on that. So let's see if that works. So that's not working at all. Okay. So that's fine. Unless it is working. It's kind of frozen up right now. Oh, it hasn't been analyzed. Analyze it now. Yes. And I think this is a... Oh, maybe it's not ARM v5. I might have to try around. It looks like we had better results with the other one. Analyzer's this. EOR sub, compare greater than. This kind of looks bogus here. I don't know if there's a way that I can tell it to decode everything in thumb mode. But unless this is working, this looks kind of sane here. In bad instruction, truncated. Okay, I don't think that's working. Let's see, close this, don't save. Maybe we can, what's a good, anyone have like pro tips on to how to quickly figure out the thing? Yeah, ARM Cortex R4 thumb only. Looking at the bytes, yeah. So I don't know if there is a way. Oops, I think I need to kill it and reload it if I want to change the architecture. ARM V4 thumb. Oh, V4T, I'm guessing. I'm gonna guess that that is thumb mode, and then I don't know if it's little or big endian. Yeah, T variant here. ARM thumb, T variant. So we'll see if this works. Yes. Analyze. Does this look better? Ooh, this is looking a little bit better. Not 100%. We might still have the endianness wrong. Cortex M3, the spec sheets. Oh yeah, let's take a quick, we can take a quick, drag this. We can take a quick look at the guide for it. So BCM 4330, and we'll see what this looks like. Preliminary data sheet. Yeah, R4 is the real time. So I'm hoping ARM, let's search for ARM here. This is saying integrated ARM Cortex M3 processor. Okay, do we get more details? Man, I feel like I've never seen this data sheet. RAM, ROM, and patch memory. Yeah, this is like information about that. Oh, I probably have seen this before, but we'll probably be referencing this a lot. This is saying the ARM Cortex M3 processor, low power, blah, blah, blah. Implements the ARM v7M with support for Thumb 2 instruction set. So this says v7-M. I'm kind of surprised that it's not an embedded one. Okay, so let's just do v7M with Thumb and see if that works a little bit better. And I don't think this told us anything about the endianness, so we might just have to try both and see which one gives us the most instructions. So let's import a file here. This is blah 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 on MIPS. Okay, so we'll grab this. Let's say this is an ARM v7. There isn't a T thing. I wonder if there's a way to specify specifically that I want Thumb only. I don't know if that's an option. So I can say v7 little endian, and we can just see what happens, and maybe it will automatically do the Thumb stuff. Otherwise, I don't know if there's a good way to specify that. There has to be. So this will open up. We'll get the analysis pop up. Here we go. Let's see if we can specify something in here for ARM that is specific to ARM pre-pattern, ARM, tailored recovery. Same as in IDA. I just like do the Control G or whatever it is to set the thumb bit. In the CPU settings. Oh, I didn't see that. Let's see. Maybe this is just gonna do a decent job? I don't know. It looks like that analysis kind of stopped. Yeah, it's not using thumb here. Okay. Let's just kill this, and we'll see. We'll try and look through more of the options. But I didn't see one. I saw like a thumb specific mode for let's see. So we have ARM, we have v7, but I don't see like an option in the CPU settings. I mean, this is like where I select the language and compiler. I don't know if it's big or little endian. It doesn't really tell me. I could probably figure that out pretty quickly. Maybe I'm just gonna try little endian again, and we'll see if we did have anything that let us specify thumb. This guy. So the options here, there are no options for the processor that I'm aware of, and here's just the same language pop-up that we had before. So ARM thumb v7, little endian. Shit, and now that's hiding behind. Yeah. Damn it, I keep hiding it. Binlock A will report on opcodes if it finds it. That'd be kind of cool. Do I want to analyze it? Yes. And like here's where I would expect if I wanted to tell it thumb only. I would hope it would be like here before it actually starts trying to do anything. I could also maybe not do any analysis at the start, and I could just Okay, so let's not run analysis at all, and we will try to see if there's a more specific processor feature or processor like options. So I know there's configure, but I don't think this is for the processor. This is like plugins and stuff. We might have to look back in there. Auto analyze, one shot. This is to do like specific things. Search, matching instructions, program highlight. Yeah. Do you know that this option exists or not? Or are you just guessing that it's probably a similar thing? I don't actually even know where the options are for the processor. Options for this: analyzer, decompiler, disassembler, program information, raw binary, firmware path, created from this. I'm not quite sure. What do we got? We also have tool options, auto analysis, decompiler. I want like disassembler, processor manuals. Okay, program tree. Used it earlier. Where did you find it? Like, was it in? Do you remember where it was? Auto analysis. Options for that. Unless there's yet another one for specific architecture options. Processor manual, program differences. None of these look terribly relevant. Yeah. Installed processors. These are like all the supported things. Unless it's one of these. Select addresses, imports, exports. This, create C header. These, I think, are all shortcuts to things we have up here. Options for this, for the analyzers, calling convention, ARM thumb mixed code. Right click on the code. Disassemble as thumb. Yeah, I can do that. I don't know. I would ideally like to tell it that there can only, processor options, T mode. Okay. T mode, we set that to 1. Okay, I didn't see this before. Cool. I wouldn't have even thought to look there. That would have been like the last place I would have checked. So I'm guessing we can just set T mode to 1. And let's just see what happens now. There we go. That looks really good. Sorry. How do I foreground that window? Is it because these guys aren't tiled up? Yeah. So, okay. We'll just keep this here. So I think that these look pretty sane. Load ADR, load byte. This is the like information about some string, I guess. It doesn't seem to be identifying a lot of code here. I don't know if it's analyze it. This looks well, that's saying bad instruction. Like, I'm trying to figure out if this is a coincidence or if this is actually supposed to be a different endianness. I can't remember what we picked for this. Yeah, it's kind of a weird place for it. It makes sense. That's kind of how IDA has it. Is this just a complete coincidence? Because it looks like it just hasn't found a lot of code. And I'm guessing these definitely look like instructions. Let's just disassemble that. Yeah, those look pretty accurate. Those look like instructions. I think if we had the endianness wrong, this would be a lot more incorrect. Let's try this. So far, I've had it detect, I've had it like find functions. The auto analysis has been pretty solid. Let's try the aggressive function finder, see what happens. I think I had to use like an IDA script to find where there's still a lot of questions. These are just things that haven't been defined as code. Yeah, that's actually undefined. I mean, we could, I don't know. It's hard to say. SDMIA, that looks pretty pop PC. Like, this looks, oh, assume T mode is 1, LR set. Yeah, I did run the analysis, right? Unless there's a pop under. But, like, I have a question about Ghidra. Can we debug? I'm not aware of any debugger integration with it. Auto analyze all open. Ooh, this is new. I don't know what this is. 0%. What is it doing? Do I dare hit cancel? Oh, I clicked cancel and it didn't do anything. It might be stuck here. We'll give it like a couple seconds, and if it doesn't come up, then we might have to hard kill it. I have a pop-up here. This is some information. Do I have a pop under? Maybe my window manager is gonna bite me in the ass here. But like this one, I can't click on like any of these buttons. This one is frozen. This one's fine. I didn't want to tick that. Okay. Let's see if that worked. Oh, I see. Okay. Yeah, I'll try it again. See what happens. Try it again. So, but we know it's ARM v7. But delete that. Create a new. Grab this. Pick an architecture. ARM v7. Little endian. Unless it's big endian, but I don't think it is. We'll try it quickly and throw it in the trash when it doesn't work. Because it probably, I don't know. The other one looked pretty sane, so we'll say we don't want to analyze now. We're going to set the processor options. We're going to set the T-bit to 1, and then we'll run auto analysis. Oh, is that it? Is it big endian? Load high. I feel like we're just in the same spot, and I don't think analysis is really running on this at all. Let's see. Auto analyze all the default options, and it's just not really finding anything. I think the little endian looked a little bit more correct. Is this one a coincidence? Yeah, this one looks pretty garbage. Ooh. Huh. Yep. We'll delete this. We'll try the little endian. Or we can use binwalk, maybe. Your problem is I'm not at the right address. None of the function calls work. Oh. But shouldn't the function calls be relative? Unless they have some weird jump table stuff. So this is why I like to go into the actual dumping of it. So let's see if we can do, I think linear, oh, that's a linear sweep that I wrote for IDA. Let's see what this looks like. This is looking for push. So I've done a little bit of reversing on this like way back when to try and get it into IDA, and I had similar issues. Let's see if we can get this up and running on the new one. So we'll go into, what did I call it? Create elf. So is that where I saw the firmware? Because that's the address of where I dumped it from. Broadcom BCM 2049. Oh yeah, using the function, yeah, the ARM tables. So if we look at HCI, where did I thought I had this written in Rust. I think I do somewhere. This is me trying to figure out, okay, I have some information on it. It's an ARM core, blah, blah, blah. How did I not note the endianness when I wrote this? That's kind of frustrating. So this is something that actually communicates with the Bluetooth device. This communicates with the Bluetooth device via serial, the TTY S2 that you saw in the config options wherever in here. And it's just kind of like a standard HCI sort of thing. And I can't remember what I was doing here. I think I have a better one written in Rust. Let me check a different computer quickly. I'll be right back. Where would this be? Here. Like, I'm pretty sure I wrote this in Rust. I'm gonna be sad if I lost that. This one, nope. Ooh, where did I write that code? Maybe I named it something? Let me check. Let me check something here. Yeah, probably didn't write it down because it's just a little Indian. Yeah. Let's go in here. I'm pretty sure I wrote this in Rust at some point. Oh, is that web server not up and running? Let me, oof. And I didn't have my Git server running. I think, oh, I just moved my computers around, so I had to run it. Where's that? At Git and, ooh, that looks pretty solid. Counts. Where would that be? Here. Hey, I have a Git server again. Woohoo. Okay. I'm just trying to find where I stashed this code, because I swear I have it somewhere. Can I scroll back to those notes? Sure. Sure, of course. I think that was in HCI comms. So this is right here. So I kind of just did binary searching of all of the memory to try and find where these things are loaded at. So they have a ROM on the chip, and then I think the firmware that you see, and that might be why we're finding very few functions, I think the firmware itself here is actually put into RAM. Yeah, it's tiny. I think this is just diffs and patches, so I don't think it directly loads up. So where the hell would I have put this code? Oh. So we will... L. God, I know I wrote this. I'm searching around on like all of my dev machines right now to try and find where I possibly could have put this. Unless I did it recently. BCM DHD, yeah. Yeah, and I'm guessing that's why I'm not finding anything. Oh boy, where did I put this? Unless I... God, there's a slim chance that I did this on a machine and like threw it away because I didn't think I had anything on it that I cared about, which is gonna make me kind of sad. It's not in there. Backup. Hopefully I didn't lose it. Backup privacy dev. Is this it? No, that's a different thing. Ooh, that's kind of cool. Oh, you know what? That might be it. Unzip list files of this. And then we'll grep for, oh yeah, this looks pretty good. Bluetooth dumper. That looks solid. And that looks like Rust. And we got Bluetooth docks. Good. Okay, unzip. Sorry, I'm just doing this up on another thing because I don't know what's in the zip file. Unzip dev.zip. And I think I can give it a list of file names. Couldn't find that. What are you talking about? Unzip. Unzip, give it the file, and then I can give it a list of things. File name not matched. Did I make a typo? I'm trying to extract a specific file out of the zip, and I just forget the syntax for it. File name not matched. Say stole and deleted it. File.dev.zip. And then I'm just giving it the path of the thing. Star? Oh, I had to give it an asterisk. Okay. That makes sense. And then we'll copy this. Bluetooth this to Bluetooth reversing, and hopefully we now have a new file. This one, and it's in Rust, which is what we want. So, okay, so we have a simple little thing that looks like it's going to dump these different ranges that I've identified before. Let's take a look at this program. Yeah, I know there's a bunch of info. I don't want the spoilers. So what we have here is this is a MIPS Rust, a Rust program for MIPS Linux. So we used the libc crate and we make our own allocator. Did we have to? No, we could use the system allocator. So we have HCI here, and let's %s tabs. Right? How are these spaces? I don't know why this is mixed. 1, 2, 3, 4. Okay, this should be a little bit cleaner. All right, so let's kind of see what we were doing. Let's look at how we enter. So we start by, we set the buffer for standard out to 0. So we disable, this is disabling buffering in the console. I use this a lot if I'm having issues with flushing to the screen. Here I make a new Bluetooth serial device of dev ttys2. In this case, I am not, I'm using libcore, so I'm using open, so I have to null terminate it manually. I could use like a C string in Rust, and that would be a little cleaner, but this is kind of quick. Yeah, you can link the site in the chat, that's fine. And then bt dump. So let's see, when we create a new Bluetooth serial device, we take in a file name, we open that as read-write, and then we just return the FD kind of in this enclosed structure. Yeah. And then we grab this is to read bytes. I'm guessing this is creating a command to send to the Bluetooth device. This is like a read memory command, and we're giving an address, and we're adding the bytes here. Adder plus equals bytes. Is that right? Adder plus bytes. Okay, and then we go into here, we do just a libc write and then a libc read to read the response back. and then we update the response length. We make sure we read the correct amount. Then we start parsing the HCI packet that we received. We make sure it's an event, a command complete, the length of the bytes, the number of command packets, the opcode, status, whatever. So, yeah, the WLAN stuff I'm familiar with, but the Bluetooth stuff, to my knowledge, is quite different. It should be the same like processor and like architecture in that mindset, but it's completely different code to my knowledge. I could be wrong. Then this is going to dump a range. So here I'm just going to give it a range of addresses, and that's what I use here. So I just call bt.dump, and it knows that these are certain regions in it. So I kind of already did that before, but it's kind of boring, so I'm not going to go and redo this. But I literally just went through like each page, and I kept trying things, and when it gave me errors or when the Bluetooth device crashed, and I kind of did a binary search to find where these regions were in memory. So let's see if this works. Cargo, I have a make file here. Nice. Cargo, rust up target add. So we're using the MIPSL on the Linux GNU because at the time that I wrote this, there wasn't an Android target for MIPS for Rust, and I still don't think there is. So we're just building it for a generic Linux. rom.bin, we don't need that. Cargo clean, build, make. So it cannot find the system alloc crate. That makes sense. This is something that was probably deprecated. Let's see how the new syntax of this is set up. Sorry. Yep. Grab this tab. Move that here. Okay, so Rust system allocator. What are you sending to it, and how did you figure that out? Long story. We might get into that a little bit later. We'll see. But there was if you search around a bit for the device, there is some documentation that probably shouldn't be on the internet, but is that you can find ways to read and write arbitrary memory on the device and also jump to an arbitrary location. So I actually haven't tried the jumping to an arbitrary location yet, but I think I can do alloc system. Can I? Why is that complaining? Global allocator? Is it complaining? What is it complaining on? So, can't find create alloc system. Well, that's frustrating. So, I'm curious. Like this, I think it's still the same stuff. Let me actually pull up the modern Rust up here. Rust up doc, and this will be the documentation for my specific Rust. And we'll search for system allocator, maybe, hopefully. Rust book. Where was that other document? System allocator Rust. Yeah, I kind of cheated and got lucky. Oh, is it just this? Wait, I can't use standard. Let's see if we can find alloc in here. Oops. This will probably give me a lot of hits, so this might not be good. We want alloc, core alloc. It's okay, we can do experimental stuff. Alloc, dealloc. We might have to quickly implement an allocator. They might have killed the global allocator, maybe? Core, okay. Global alloc. I feel like a lot of these we'd be able to use. It's not cheating. It's not cheating if you win. Yeah. So alloc system. This is maybe called alloc global allocator. Wait, what is? Let's see what this is. There's also one in core. Memory allocator that can be registered as the standard one. Currently allocated. Let's look for system, maybe. Standard alloc system. Okay, so it doesn't look like they're... Man, Rust used to have this for MIPS, but I guess maybe they don't anymore? Like, global alloc is how you implement allocators. So I think we might just have to do that. Let me grab this. We're going to have to write a really, really quick Rust allocator, I guess. Huh, that's frustrating. Why did they get rid of that? Alloc system. Let me, let's see if I can find alloc system Rust. I want to see like where they deprecated it or something. Alloc JE malloc. Remove the alloc system crate. Okay, why? So this happened just recently, like 2 months ago. Just overflow your stack and never return. Okay. The default is JE malloc. Can I just... This is the downside to this type implements that lib standard alloc. Did they really just put this in standard? So they had something that would have worked before if you didn't have standard, and now you need lib standard for this to work? If you want to just use the global allocator, that's really annoying. Okay, so we'll just go into here. It should be pretty easy to make a new allocator. So my allocator, whatever, we don't even have to rename it, we don't care. And then alloc system we get rid of, alloc system here we get rid of, and then we'll open up a another terminal. CD Bluetooth, start term and exit. CD Bluetooth thumper make. Can't find collections. I think those are in alloc now. This code is probably like a year old. So null mute. Okay. Core alloc? Is that where it is now? No, it's not in there. Watch me port old Rust. Yay. And after that, Ghidra. Core alloc. Global alloc. I need to implement these things. That's fine. That's easy. But where's vec? Where can I find vec? Vec is found in alloc vec. Right? Isn't that what I'm doing? Use alloc. There we go. Maybe? Panic format has changed. Global alloc is now used. Blah, blah, blah. Use alloc and then layout. We're getting there. We're making progress. And use core pointer null mute. Yep, this is the beauty of reverse engineering. Panic handler, unstable crate. Unless there's also a core alloc vec, but I don't think there is. Core alloc. Core alloc, yeah, that doesn't have it. So we'll just have to bang feature alloc. And then panic format, they changed how they do panics now. Standard, I think I have this source core requirements. That's where I implement some panic handlers. So let's update this to the latest layout, which is panic handler. Ooh, alloc error handler. I haven't seen that before. That's new to me. Panic handler Rust. I also have a panic handler somewhere else, but I think it's pretty easy to set this up now. This is, we're just grabbing some Here we go. Oops. Stop. No. Set, paste, copy, and doop. What? Why did I get line numbers in there? There we go. The beauty of dev. Panic. That looks like a good panic handler. Unknown language item. Yep. And then we'll grab this. And here we'll do this. And I think panic info now has all the fields I want. So let's just search for panic info. Core panic. Oh, I do have an image that's extracted, but I want to make sure I'm on the same version that we're all kind of on. So I think there's location. What is location? I wonder if I can just debug print that whole thing. Apparently it implements debug. Set no paste. Let's see if this works. That would be nice. Beautiful. Okay, alloc error handler. I don't think I've seen that. That one's new to me. Alloc error handler. This is probably something simple that we can just like have it panic or something in. What does this look like? This went in a while ago. Alloc error handler. Tracking feature is this. Sorry, I'm just like searching the lang items this similar issue. I might have code for this somewhere. I'm just gonna quickly look at one of my other OSs because I think my other OS, this OS can currently build, so it should work. Ag for RG for what are we looking for? Alloc. Huh. Maybe I don't have that. This might be a new thing that I don't have. So, alloc error handler, where can I find an example? This looks like fairly old. I'm surprised. Let's just try it, maybe? See what happens? Just put this in here. See what happens. Panic. Alloc error. And then we need that feature. Alloc error handler. Unknown feature collections. I think that's fine because we have it in alloc. Oh, we're close. We're close. Yep, that path doesn't exist. I might have to get an old Android NDK because I think Android officially deprecated MIPS in like Android 7. Let's grab one here. What did we use here? We were using R13B. So hopefully this has historical ones. I just want downloads. Downloads, this, I have red, we don't want that, we want the Linux one. Hopefully I can get this path. And then hopefully I can just change this R19B into R13B. Beautiful. So that will download. Why Rust? It's just a lot easier to work with for larger projects than C. I had this originally written in C. Obviously, it's giving me some pains here because I haven't touched this code in a while. But it was really nice to be able to just print things and print things to the screen when I had issues and be able to do assertions and stuff. I don't know. To me, I've been doing pretty much everything in Rust for the past, I guess, 2 years now. So we'll go back here, we'll move downloads Android NDK this Please don't explode over my directory. Thank you. Where's the Ode button in Ghidra? Oh, it's all over the place. You can get Ode anywhere in Ghidra. I heard someone already has Ode in Ghidra. Let's see. Oh, look at that extraction. This machine we're on right now is really old. It's got like an ancient Xeon from like 2010, so it's pretty slow. I mean, it's like a 24 core machine with 48 gigs of RAM, but the cores themselves are really slow for anything single threaded. So what path do I want? I want to go back to make, and then we'll just find this path here and we'll just replicate it, I'm thinking. Home pleb, Bluetooth reversing, Android NDK, 13B, toolchains, MIPSL, 4.9, pre-built, Linux, bin, MIPS, Android, GCC. Hopefully that will do us a solid. That's gonna be this. Yeah, I guess I did this on Windows last. So this needs to be the GCC path, and then the other one needs to be the path to the sys root, which will be pretty much similar. I think we can just change this to home pleb Bluetooth reversing. Yeah, that'll work, right? Of course that will work. Please, please, please work. No, no! Stop. Linking with that failed. Why? Couldn't find LRT. Oh, shit. What was my workaround for this? I remember running into this issue because Rust automatically adds the like LRT stuff, and I need a way. I ran into this before. I can't remember what my trick was, and maybe we will just grab this, the whole thing, and just try and run it ourselves. GCC. Let's see if we can run this command. I haven't. Shit, I can't copy the whole thing. I don't know a good way of copying in Xterm that you can scroll. Someone has real Ghidra Ode today, not the shitpost one. Some XXE and Project XML. Yeah, I could see that. I don't know. I mean, I can't imagine Ghidra was being used on any internet-connected machine, so they probably didn't really give a shit about the security of it. But, boy, what was the solution to this problem? The problem is Rust is like automatically adding these lines that I don't need. So I could maybe manually try to link it. Home pleb, Bluetooth reversing, Android NDK, toolchains, MIPSL. This and target debug depths build. No, what? Incremental, negative. Let's just do an ls. God damn it, I bet it's just I think, what are the paths? It's passing debug, MIPSL, target. Whoa. Target, MIPSL, debug, build. Was it debug build? Sorry. Debug depths. There we go, that looks good. Star.o. Oh, that's not gonna work. Cargo clean, make. And this needs LC LDL. Oh boy, what else do we need? We need to pass it the sysroot. System, platforms, Android 24, Arc, MIPS. I really hate the like smart tab completion. On to find a reference to this. Yeah, this. All right. What on earth? I know I have fixed this issue. Cargo config. Missile Linux GNU. Like, I literally just need Rust to not pass these things. It would build if these weren't passed in. Why is that not? What? What? Isn't it that? We'll just do this then. Whatever. Okay, so let's just rip this crap out and this is really hacky. I'm not happy about this. But this might be the only way, and hopefully we only have to build it once. Okay, so this should give us the same issue. Yep, good. LRT, LM, and what is it? LRT, LP thread, and LUtil. What do you guys think? Oh yeah. Where did that put it? Where did that output it to? -O home, target, deps, MIPS Rust, Bluetooth dumper, target, debug, deps. Okay. Oh, I saved the built binaries. This is not a Rust problem. This is Rust does not support building for MIPS Android, and I am building for MIPS Android. And MIPS Android doesn't have these like standard libraries. It doesn't have LRT, so you need to just omit those. What is that? LS target. Target, MIPSL, debug. Where was it? Native? Was it? Debug? Build? God damn it. I'm having a really bad recall right now. It's looking at -O. Debug deps MIPS Rust. LS target MIPSL debug deps MIPS Rust. And then file. Okay. ADB push this to data local temp BT dump. Data local temp. What? Where's a good like temp location here? Why is there no data local temp? We'll put it in data maybe? Read-only file system. Fuck. What is not read-only on this? Tempfs on dev, blah blah blah, procfs on mount, dev block, storage. Maybe that will work. That looks good. Failed to open file for dumping. Geez, hopefully we don't have to change the Rust program. Oops. Failed to open file for dumping. That is the... Is this the output file create? Where is it trying to put it? Data local temp. Yeah, that's really weird. That's kind of strange. What is in data? Mount T, tempfs, tempfs. Right. Now we're hacking. Alloc error. Oh shit, we didn't implement the, okay. We are gonna have to rebuild this, but that's fine. We know how to build it now. So we forgot to write an allocator. So this alloc is going to call libc malloc and layout dot, let's see what the shape of this structure is. I'm just searching in my Rust docs. Layout core alloc dot size. That might just work. It should. I don't think it's set and forced. So that's a C void as mute uart, right? And then we're just gonna completely ignore the we're gonna completely ignore the log.txt. We're gonna completely ignore alignment. Hopefully it's not requesting anything with a crazy alignment. And then we're gonna do the same thing here. I know I found a fix to this at some point. I can't remember what I did. I don't think I had to custom build Rust. But yeah, these are built-in. LC. LC. Oh, we didn't want that. We wanted, I think, these three. That looks good. And then we're gonna have to change this to mips rust data local temp bt dump. That might be working. I don't know if it prints on an interval or what. I think that alloc is fine. Sorry, I need to catch up on chat. You got decompiler to catastrophically fail. I don't remember if I have status prints in here. If index, is that print status? Looks like I should have status prints. Let's see. Do I have strace? It's blocking on that. I think, oh, you can't do AUX. PSA? PSA, PS, PSA, PS. Why is PS so nerfed? PS. Cap A. Kill 9, 146. So I think the other Bluetooth, or the actual Bluetooth process was using it. And maybe that's what was getting me. How do I might have to like nuke this pretty hard. System Bluetooth? Where was the Bluetooth stuff? Find system grep blue. Yeah, system ect Bluetooth BT stack. Of course, there's no Vim. I don't think there's anything on this device. Fuck. Just sig stop it? What's sig stop? But is that going to cause it to relinquish use of the, is that going to relinquish the open file descriptor that it has? Let's see if I can do this syntax on, let's do the PS. Kill sig stop 293. Okay. We'll see. I might need it to close that handle that it has open. But I'm not sure. Yeah, why is that trace? It's just blocking on that. Open that. And this is blocking on a read from this. It was able to successfully write to it, but it couldn't read from it. The problem is I think I need it to close that handle. Unless... So I remember having this issue a lot, and getting control of this CTY device was pretty tough. So I'm going to see if I can edit that file. Yeah, I think it's a unique owner of the device. So I'm going to just break it, and hopefully everything will be fine. So we'll do ADB pull system act Bluetooth bt stack.conf. And I think this had the TTY. Was it a different one? Ah, it was a different one. BT stack. There was also BT. What else? Device ID vendor.conf. Oops. Oh, that looks good. Right? Dev. No. Hopefully that, Ooh, what's tough there is I might not be able to get it to correctly load up that firmware if I do this, but whatever, we'll try it. Oops, dev, no. ADB push BT vendor data local temp. And mount grep system. Let's see if that is read only. Mount remount RW system. Okay, copy this BT vendor to wild should kill. System X Bluetooth BT vendor PSA grep blue kill 9293 PSA grep blue. Yeah, it's probably that might be okay. There might be a command I have to send to it. I might actually need the opposite. I might need the Bluetooth thing to initialize it, because I think I might be relying on it being initialized. Well, dev tty s2, I think. Let's see, tty s2. Yep. We'll copy that. That might be what it is. Kill 9337, and then I might have to enable Bluetooth. I think that's what it is. I think the device is not initialized because I'm like operating in like a really weird state. So I want to send a command to it to enable Bluetooth, but I don't have a GUI. Android enable Bluetooth ADB. I know there's like you can send it a service called Bluetooth 3. Service list. What? 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 Why do I not have a Bluetooth service? I wonder if this build has like a broken Bluetooth. Yeah, whatever. So let's we'll just open up an old one maybe that we have. CD Bluetooth dumper. I might have some historical ones that I could grab. File rom.bin. I just wanted to go through the process and be on the same one, but if I can't do that, then whatever. CP. Ooh, an AM command. Is this new? I haven't done any Android. I think that just... Cannot find service activity? It might be a little broken. So let's, we'll just cheat. I wanted to go through and, like, actually find the, I thought it'd be fun to try and redump it, but whatever. So we have rom.bin, which is the, I think that's the location at 0. Rom.bin is at 0, and it should be that size, Python hex 589.824. Hopefully this dump is good. But yeah. Anyways, yeah, I don't know. It's a bad Android. Yeah, it's kind of weird. I'm not quite sure. Anyways, we'll open up, where's that Ghidra at? Let's start closing these windows. Okay, Bluetooth reversing. We're gonna open up, we're gonna go up a directory, grab rom.bin. We said little endian v7 arm. We want to load it at 0, which is actually where it is, because this is a memory dump at this point. This is not a firmware image anymore. Oh, did I tell it to analyze? Oh, no, that's probably a pop-up. Would you like to analyze? No. And then set the processor options, set the T-bit, then auto analysis. Let's go. Please. It's doing stuff. Yeah, sorry. That was probably a little bit longer than I should have spent on that. I just thought it'd be cool to get it working on this very specific version, so it was all synced up and everything, but whatever. I'll just use this old one, which, honestly, I can't imagine Broadcom has changed their firmware at all. So, I just wanted to go through that process, but, you know, I mean, that's hacking. Like, if I didn't have this image sitting around, this old firmware image, I would have had to, you know, gotten all of that toolchain to work or somehow get Bluetooth working. I'm guessing that this version of Android that I put on this device maybe is experimental and they don't have Bluetooth working or something. I don't know. Is it possible to turn off the Dragon? Why would you ever want to turn off the Dragon? The Dragon is what made me excited when I opened this tool for the first time. These are pointers, not code. Yeah. Oh, these ones? I mean, it varies based on, it varies on different ARM processors. Sometimes they're pointers and sometimes they are not, right? Sometimes they're actual instructions, if I'm not mistaken. And sometimes they'll have it fall through to a branch. I don't know if it is in this case. These might be pointers. But I know I've worked with ARM processors before that actually have instructions, which is kind of strange. And they would usually have something where they'd like load in unique values, and then at the very end they'd have a branch to go somewhere. But I don't know if that's the case in this one. So, in fact, I think this might be correct. Yeah, these look pretty pointery, but whatever. It looks like, man, it did a fantastic job of finding functions. Like IDA, I had to write a custom linear sweep thing. Oh, these are nice. So for IDA, I had to write a custom like linear sweep sort of thing to get it to even find like a couple functions. But man, it found like everything. Okay, so let's see if we have any strings. And then we'll just start navigating through Ghidra, I guess. Let's see what it has to offer, kind of starting from the top. I think this analysis is done, and everything here looks really good. This looks exactly like what I'd expect. Maybe there are certain things it didn't detect, but like it did a really good job. And this code definitely looks legit. Yeah, the auto analysis is crazy for firmware. Like IDA really struggles, and you have to define code. I'm really impressed by this. So, okay. So now that I have this, we might eventually have to get the firmware dumper working. I could also maybe switch to a different phone. But one thing that, if I have my tool actively working, then I would be able to read and write things, and I'd be able to point things in. Am I going to start from the boot entry point? Hell no. But let's go there. Let's assume this is a pointer. OX00200400. Oh, is this big endian? No. Oh, you know what? I think this might be in the other region. Let me see if... Let me look at my notes here. Yeah, so that's where the RAM is. So it looks like this is patched with something in the ram.bin, which, man, I don't think I have a RAM sitting around. Oh, that sucks. I could maybe try to put a different Android image on it. Let me, I'll set that up. So I think ultimately for us to be effective at reversing, I am going to need to probably get this working so I can get the RAM loaded up as well. Because this is only the ROM, and the RAM is used to patch a bunch of things. And as we can see here, the, whoops, is there a, yeah. As we can see here, this vector here, and let's see how I clear code bytes, and how do I define this as a, let's see, clear code bytes, data, pointer, right? P, create pointer failed, instruction exists at address, oh, I need to undefine this. So it's similar to IDA where you have to undefine that. So this pointer is not present in the image, which makes sense. But this one probably will be. Clear. I'm trying to learn the hotkeys. So this one is, which vector did we just pick here? This was undefined instruction. We go into here, and clearly it had the +1, which means it's thumb, but everything's thumb mode. Couldn't detect a jump table, but it's got some print, some like setups here. I mean, it's working with a string. But yeah, so it looks like they overwrite the point here. So let's let me find CD Windows CD dev computers CI20. Android 712, July 5th. So I think I have a custom build of Android 712 from July 5th, 2017 here. And once again, we only care about this firmware, which probably isn't changing. But what's nice about this is I actually have full symbols for this build. Because I built this one myself. So I'm going to Yeah, it patches everything. So I'm going to, this will probably kill my ADB connection, and we will flash this image onto it instead. Can you pull up strings? Yeah, I'm gonna start this DD. I'm gonna need to be root, sorry. Dmessage, ddif equals ci20.image, of equals dev sdc bs equals 1 meg. Okay, so we'll bring up strings, which I think is a window, and I don't know if there's a hotkey for it. Define strings. Yeah, there are like no strings, but we can see this was a latest build. This was the like latest thing, and it's I'm guessing that's a build date, 2010. So their patches maybe are a little bit more recent, but it looks like this is more specific model information about it. This is a BCM 4330B1. Really? Yeah, they have like no strings in this. I have looked at the Wi-Fi chipset before, and the Wi-Fi chipset has a lot of strings, but this one's pretty empty. So let's see. I'm waiting for that DD to complete, and I'm gonna try and run this, get my dumping tool to work. And if I can't, then maybe I could switch to an ARM phone. I don't know if I have any ARM. I don't think I have a rooted Nexus device. I actually don't own a Nexus device. I probably should buy one. I have all Samsung devices, which are up to date, and I don't have any roots on them. But waiting for that DD. Yeah, but let's poke around at some of the things that we can do. And this is accurate as well. This isn't like it's screwing up and not detecting strings. Actually, what's the Broadcom debug port? Let's take a little look at XREFs to this guy. Okay, so we find an ADR on this guy. So this function prints debug port, Broadcom debug port. What do you think this is? This function. This is probably like a printf, or maybe this is output to a serial. So it's like a. I have no idea what their serial controller looks like on this device, so it's hard to say. Yeah, Control-Shift-F for XREFs. What's also kind of cool, I think while we wait for this DD and we wait for the ROM, because we want to get the ROM and RAM kind of atomically from one snapshot, and then we can load it up. I've never loaded up two things in the same thing in Ghidra yet, but I'm sure they have to support it to have different sections. But if we look at some of these things, we can do call trees, and I found this to be really convenient. You're able to look at like incoming functions and outgoing functions, and it's like really convenient to be able to like look through it at this sort of level. I found this tree view to be really friendly. This is the recursion depth, incoming. What is this? Huh. On WLAN they go to a ring buffer that's never read. That's interesting. But yeah, okay, so that has finished writing to the SD card. And we can pull that. And hopefully this Android will be a little bit more sane, because I think this is probably one that I've imaged before or done these tests on. So yeah, this is really cool. So I don't know. Maybe I have ROM dumps, ROM and RAM dumps. Like clearly, I don't know why I have a ROM bin, but I don't have a RAM bin. I might have to look around a bit more. I have to have images. So this device is booting up. ADB shell. So now we're running on like a more sane Android, an Android that I'm more used to. So hopefully. Oh look, we have a data local temp. Jesus. Okay. So let's see if this just works. And if it just works, then we're going to be really happy here. Bluetooth dumper. You know, one thing I've never learned is how to look at history in terminals, which makes no sense. I've been using Linux and FreeBSD and Unix and deving on them for 10 years, but I've never learned how to go back and scroll back history. It's kind of embarrassing, but whatever. Please, please, please work. Okay, so that's not working. I think it's doing the same thing. Yep, so let's see if we can get Bluetooth up and running this time. Service, wait. See, that looks more like Android. And we should have a Bluetooth manager. Yeah, so now that command should work. So let's see. We're just gonna try and bring up that service, which will be, I think this is the equivalent of pressing the like enable Bluetooth button. Service call, not Bluetooth. I'm literally looking at Stack Overflow for a command. Whoops. That looks good. What do you think? Is it gonna work? Fuck. Unless it's a different service call. I think I have seen different ones. History grep, control R. Ooh. What's this one? What's this? No, that's someone who like wrote a quick app. PS grep blue kill 9 1098. I've had this issue, like, getting exclusive control, so I'm not, like, setting up this device for use. I was relying on Android kind of already setting it up. Unfortunately, Bluetooth manager, start Bluetooth. Control R, you can search. Oh, okay, so that's gonna look back, case insensitive, I'm guessing. Oh, that's pretty cool. I don't know why, like, I don't know little things like that. Okay, Bluetooth, Android, start Bluetooth. Here, you can enjoy what I'm doing. Android, start Bluetooth, ADB. And ADB connect. That's not what I want. I'm trying to think. I don't think I can get a display. Oh, there is a, actually, I have a... I have apparently an HDMI port. Let me see if I can get that to work. 1 second. Be right back. Where would I have an HDMI cable? HDMI cable. I will be back in like 2 seconds. I have to move some laundry, which will take 2 seconds, and then I have to find a HDMI cable. And maybe I can find my capture card so you guys can see what I'm seeing on the Android device, but I'm not sure if I'm going to be able to get that to work on Linux. So 1 second, be right back. Apparently HDMI cables are really hard to find in this household, even though I buy them in bulk from Amazon like weekly. I don't know where I have them, but alright. So, let's grab a monitor, and hopefully we can, get a terminal? Alright. Yeah, I'm back. Sorry. So now I should apparently be able to plug in this, and I now have a mouse on Android. Okay, so I'm literally just going into like the settings menu and clicking the Bluetooth enable option. And hopefully Bluetooth will actually come up and work. Sorry, there's a really big stream delay. I think I picked like a really long delay or something. Bluetooth disconnected. On. Okay, it's finding devices, which is a good sign. God damn it. Maybe I need to do the opposite and turn it off? Oh, it looks like it read a couple, right? Yeah. Oh. So it's stuck there. See if I turn on Bluetooth. Like it went through a couple. This device is really slow. Bluetooth. When Bluetooth is turned on, you can communicate. Yup. There we go. I don't know why I'm not getting output to the screen. We were seeing a print, right? We were seeing it print on this version. But like it's... Open that. Why is it not writing to the screen? Okay, and let's maybe toggle Bluetooth and see if we can get this to work. Like it's kind of working. This is about how well I remember this working before. What I need to eventually figure out how to actually initialize this entire Bluetooth device. And then if I could figure that out, then I would be able to hopefully do all of this myself. And I could just kick Bluetooth off of control of this device and completely own it myself. So, I don't know. They're probably both fighting over the Bluetooth stuff, the Bluetooth serial port, but I need it to be initialized. I think I need to like kick it off like halfway through or something. But I think if we were to look at the Bluetooth process, it would be reading the, we might be able to sig stop it. PS, kill stop. You said I can do it without sig stop? 1574. What? I wonder if my Bluetooth crashed? Well, now Bluetooth isn't running at all. Let's see. We would have to power cycle the device or something. I'm like trying to navigate and get Bluetooth up and running. I need Bluetooth on, but I need to stop the scan. Because right now it's like scanning around for things. Bluetooth settings, we'll just go to the home page. There we go. So now we're on the base. Kill stop 1617. Fuck. Yeah. If I turn Bluetooth off, well, that's not going to work because I have that stopped. So now I have Bluetooth turned off. I could maybe try to figure out how to initialize it. I just don't know how complex that process is. So unticking the Bluetooth box seems to stop Bluetooth entirely. That should have it up and initialized. I know this tool works. I think there's like a weird state that I have to get into. Maybe we'll turn Wi-Fi on too. Come on. Is there a way to make Ghidra not instantly open your last project? I don't know. I haven't run into that yet. But I think I've probably been closing everything when I've been before I exit Ghidra. So I'm not sure. Okay, so Bluetooth is like up and initialized. I can't remember if it's like a lucky state that I can get it into. But I know there was some like magic sequence that I did to reliably get this to work. And I just have to rediscover what that is. Unless it's on a different TTY. No, it shouldn't be. TTY is 2. Read write. Open ROM bin. We write to the port. Get a result. Unless we're killing it? I don't think we're causing it to crash. Because I think the ROM's always at the same location. Dump range. Yeah, like the Bluetooth icon keeps like turning off on the actual device. Ooh. What is the trick? Let's see if I have any notes in here. Nope. And this one. Ooh, I wonder if I can use those dumps. Those might be good dumps. Original firmware. Oh, these might work. I guess I had these sitting around. That is protocol contain set buff. Okay, let's take a look at these. See if we can get one of these firmwares open. Maybe we lucked out and had some old ones. Yeah, I might be killing it. Like it's very sensitive with the serial device, so I would eventually like to polish that up, but I wanted this to be more of a Ghidra stream, so I'm gonna try to hopefully we can get by without. So we'll delete this Bluetooth reversing. We will add a new thing. This will be from HDI comms. We'll start with this ARM v7 Little Indian. Loaded at 0, looks good. Double click it. Would you like to analyze it? No. Now, we set the T-bit before we do anything. Set T-bit to 1. And then what we want to do is... Okay, so now I think we should be good. This looks like... 2 hours later, yeah. Sorry. Imports, exports, functions, namespaces. All right, so how do I add? I want to add another file. Import file. This, select file to import. Is this gonna just work? I don't know if this is going to import it into the current thing or not. We'll see. So this is ARMv7, little endian. We want to load this one at, this is E1234. And we're going to call this scratch. I think this is the scratch space. Okay. So that loaded it up. Is that in here? No. Yeah, so that opened like a separate one. So these are different things. Let's see if I can create fragment. What's that? Scratch. And like there has to be a way. What's this? Creates a new default tree, open tree view. All right, we're learning. Options for firmware, tool options, import file, add to program. That looks pretty good. Add to program. Yes, yes. Here we go. We didn't want that firmware. Wait, we want to, wait, how do I pick a different file? Add to program. Did I pick a file? Let's see. Sorry. Add to program. Oh, I forgot I selected it. Options. E1234. This is scratch. This is probably doing what I want. Yep. And loaded. Minimum address, maximum address. So let's see if that looks like we have a jump or like a break in memory. Unless that's just sandwiched up right after it. Oh, E. Sorry, I thought it was at C. So we have this gap hopefully here. We're just about there. Okay, perfect. That worked. RAM there. Okay, that's what we wanted. Perfect. And then add to program. This is actually a really nice way of doing this. Did I pick the right file? Add a program. This one, 200,000. 200, 123. We're gonna call this RAM. That might be a conflict. We're gonna call this act RAM, actual RAM. And hopefully that went in as well. Okay. Okay. And then we should have a big block of RAM down here, yeah. Nice, actual RAM. And then this one we're gonna rename to ROM. This one we're gonna name RAM. And save. So at this point, I think we've set everything up. Processor options, T-bit is 1. Here we go. Let's see what happens. Yeah, it's a shame that the Bluetooth dumper wasn't working, but I eventually need to just take control of it and set everything up correctly myself. I don't know the right way to do that, but whatever. That's that will just be a fun little project to do, clean that code up, and I'd probably do a blog post on it. But I eventually want to get like a debugger injected. Make sure you map to set the permissions. I think they're probably just all RWX. I actually don't know how to set the permissions. So everything's just set RWX right now. Hopefully that's not an issue. but it might be. We could, like, I don't think I had an option, did I? Length file offset overlay. Yeah, I don't know how to set the permissions. Let's see if we can figure that out. Like, these are the different locations in memory. Oh my god, I think it's, it looks like it's doing such a good job. Window memory map. Oh, there we go. Okay. So, volatile, that's kind of cool. Scratch, I think, is RWX. So, I guess technically I probably want to reload it then. Initialized. Because I don't want that to be writable. Yeah, sorry about that stream delay. Next time I'll pick the other one. I just went with the defaults, and it's like, oh, it's a normal stream delay, and it like helps with encoding, and it makes it easier for people. But whatever. So I'm actually going to start a recording now, and I'm probably going to delete this. I'm probably going to delete the YouTube VOD, and I'll end up just uploading this video, and I'll just start it off from here, because I feel like people are probably not too interested in what happened for the first 2 hours there. But that's the that's kind of the nature of things. So I think this is all done. So, oh, it will reanalyze. Okay, so I mean, I changed that, right? Memory map. That's, oh, where did that go? Where did the memory map go? It might be hiding behind some window somewhere. Memory map. I had it open, unless I moved it to a different screen. Oh, there it is. Yeah, so everything's executable. I think Scratch is RWX, I'm not sure. You need the auto analysis. Wait, what? What? Need auto analysis? I mean, I could just run it again. Auto analyze, go. We'll see if it changes anything. But I don't know. I'm pretty sure it probably did a good enough job regardless. Yeah, I can keep the VOD. Oh, yeah. Auto analysis has to be in the video. Oh, I see what you're saying. Okay. Yeah. Yep. Alright. Removing unreachable block. May have set the pointer. Okay. Analyzing functions. Man, this did such a good job. It's like, this is just nuts. Like, IDA isn't even close to this when I load this up. And for IDA, I had to like, I made a custom thing that put it all into an ELF because I couldn't set the permissions up correctly in IDA. It was refusing to use the permissions that I actually gave it. That was one thing I've always found frustrating about IDA. When you like add memory segments to the program, it really doesn't seem to like it. So anyways, so we have everything here, and we can convert this. We delete those, set that as a pointer, and this is the reset vector right here. So this will go to this. What? What? This. What? Unless this is code. Let me, maybe it didn't find this as code. What was the... Okay, so let's get data. Wait, where's the code thing? Does it not want to create code in this region? Like, it's creating code down here, isn't it? Yeah. And I think, like, that's a NOP if it is code. And undefined one. Oh, I think I have to undefine it first. Clear it and then disassemble as thumb. let's clear all these and see if we can get some thumbage going. So I don't know if these are instructions or not. Boot is at address 8. What? Is boot not the reset vector? I'm confused. Wrong core selected. Sorry, man, this stream delay is killing me. I'm just gonna take a look around at some of this code. Let's see what we have. Ooh, let's see if we got any more strings, actually. That would be kind of interesting. Define strings. We have 4? What do you mean? Boot is at address 8. What? Oh, boot is the second word. Oh, okay. Interesting. So is it this one then? But isn't that the... Okay. Let's see. We can clear these. Define this as a pointer. Go here. This looks definitely like a real function. Disable IRQ interrupts. We have a jump to this. BX to this. Yeah. I actually haven't done much ARM. Well, I haven't done much ARM stuff at this, like, firmware level. I've done mainly, like, ARM binaries. So, this is kind of all new. But let's see. We're grabbing this. Some data. So, these are to RAM. While not equal to 0. Yeah, this is not specifically the M3. Yeah. Is this... What's this? Branch and link. Carry 4. This is a little ugly here. That's fine. Let's see if we can find any strings that are interesting. Oh, you know what? These might be my A's. I might have intentionally been spamming A's while I might have been spamming A's when I was testing this out and I took the dump, so I would be able to try and see if I could see where the received packet is. And that's one thing that will be kind of tough if I'm not able to run my program. So references to address. So one thing that's interesting here, when you're working with references to, oh, I guess it's different. If you click on just anywhere in it, you can't do the Control-Shift-F, but here you can if you're on the label itself. Okay. So, come on. Oh, did it not find any references? Or did that go hiding somewhere? It probably went hiding. Or are there no references? I'm kind of confused here. Control-Shift-F. There we go. That's what I wanted. I don't know if that just took a while to load. So we've got a couple references. We've got some RAM ones. Oh, this is kind of cool. The like context tells you like if it's a param or if it's reading from it or if it's writing to it. So the write's kind of interesting of like what is this doing here? So while var6 is less than 5. Yeah, the label system's kind of strange. But, okay, so this is interesting. We saw 5 A's, and in here we see a loop of 5 times. This is filling in some memory, which I guess is constant. Yeah, PUVAR4. Is there a way in here to do the like equals thing that you can do? So like in IDA, you can do equals to assign it to a previous thing. And I don't know if that is a thing you can do here. Rename. I want to say this is the same as this because it looks like it's, or not that. So this one looks constant. var5 is used here where it zeroes it out. I'm curious if that context was actually really interesting. And then also you can't do xrefs from here? Or you can, but only if you use the hotkey. Oh wait, that didn't work at all. That is a lot of xrefs. So this one is an offcut. I'm gonna put this up on a... I should do the one-off decompiler parameter ID. Let's try that. Is that doing anything? If that's what you mean, the one-shot of the parameter ID. I'm not seeing any indication that that did anything. So let's go around. Let's take some looks at functions. What's frustrating is what I usually do is I start with strings. I like look for some strings and then I go from strings and I kind of work my way back. So one thing that I could maybe do is look for the MAC address. I actually don't know what the MAC address was of the device that I did this on. But I'm curious if I can find, I don't know if there's any easily fingerprintable thing in a Bluetooth like raw packet, but I'm mainly interested in where the, okay. It says it's scheduled. Oh, in the references window? Oh, wait, where did you see scheduled? Oh, analysis scheduled. Does that mean... Analysis scheduled. For when? It says it's scheduled. Real hackers start at boot. Oof, gross. I just go directly to where the packet comes in. Maybe if I just run the auto analysis again. Let's just put that on and see if this takes it. Okay, that's running now. Real hackers start at boot. Well, it disables interrupts. That's good. If this is not equal to this, is this, what is this as a, Oh, that's cool. If you highlight over it, it kind of shows you the different encodings. But I feel like that's not the character representation I want. That's only showing one of the characters. And I want to see like the, I want to see all of them. Where is this at in the code? Is this in the, is it this here? Data as character? Oh, copy. Huh. So, but I want to do data cycle. Oh, that's cool. So there are different cycles. So characters, bytes, so quote mark, is that like single tick? Yeah. So then you're able to cycle around between different things here. Okay, that's kind of cool. And there are different ways you can do that. Add reference, colors, set register, clear, register options. What else do I have? I mean, maybe I could just treat it as, oh, and then last used. That's kind of cool. Y is the last used type. Why did it not sync your decompiler with your disassembly? I'm not sure. Let me refresh. It's possible that it's just using as a constant. I might have to mark that some other way. Like over here, I wish I could right click and say this is something else. Find uses of ints, auto create structure, properties. Like that's not what I want. That's not how Ghidra is supposed to Ghidra. Yeah, everything can be hotkeyed. I know that. Clear code bytes, clear with options. What's this? Oh, that's cool. You can clear different things that you tick on and off. Oh, that's pretty neat. What else do we have? Clear flow and repair. All the different comments. Different data. Let's see if we set this to a C string. Oh, I might have to clear these. And then mark this as a terminated C string, but it's not terminated. Maybe if I highlight all of them and I just say character. No. Array? Ooh. Well, that's nice. But how do I get it over here? Right? Unless that's not what it's getting it from. Yeah, it's definitely getting it from here. Copy 27C. And you can like show the array here. So that's pretty neat. But yeah, don't expect much like actual progress in reversing from the stream. This is more of like literally right clicking on everything and finding like, oh, what are the options? What kind of things can I do? Because honestly, I'm probably going to quickly learn different ways of doing things and throw this database in the trash because I'll find like much better ways to do it. Your comments can include web links. Yeah, I saw that like in strings, if you have HTML, apparently it renders the HTML as the HTML. There's like a GitHub issue open for that. Set the other one to car array. Which one? Like the thing that refs it, or the... So like, I have an array of characters for this, which is what it's comparing on. We're just trying to figure this out. What are settings? Can you... Mutability, character set? Can you like do endianness on a specific... Oh, look at this. All the different character sets. And it's got all of them. Or, well, a lot of them. That's kind of cool. Endianness, little default. Where's my middle endian option? Format, hexadecimal, binary, octal character. Mnemonic style, default, assembly C. Mutability, normal volatile constant. That's cool. Padding, unpadded, padded. Render non-ASCII Unicode, byte escape sequence. That's really cool. You'd be able to like try, maybe you'd be able to show the, the thing it's compared to. This one. So this is dat, it's double dereffing this, so this is a pointer. So I might have to, let's actually see if I can do that type here. Pointer to, What? Retype global? Car star. Failed to retype. I don't know if I have slow mode or anything. I have no idea how to do this stuff. Top chat, live chat. If you maybe live chat will help instead of the top chat. I'm not sure. So what else do we have here for options? So if we take this, rename global. So because it's dereffing that, which is this pointer here. Maybe I have to change this one because this is where it's actually coming from. But I don't know how to set typing on this. It clearly found it to be... So this will be a pointer. Okay, so now that's a pointer. And that doesn't exist in program memory, which is interesting. There must be like another region that I'm maybe able to dump. I'm curious if I can't retype something. Yeah, I couldn't create data at that address. So since that's not in the database, it seems pretty unhappy with that. Well, in this one I think is a pointer. I mean, this one maybe is the pointer, but the problem is it's loading the this address, which is just like the relative, and then it's dereffing it again to get the actual data at that address. But this data is not in my this data isn't in the program, so I'm guessing I just can't retype something. But even if I did car 4, yeah, it's just not gonna let me retype that to anything. Even if I did it's like uint, yeah, it can't even do like uint. So I'm guessing, since that's outside of my program scope, it's not too happy about it. But we know that this is if comparing copy, we'll just put a comment. Okay, disable IRQ interrupts. We get a reference to this label into var4. We zero it out. So are we doing, is this a inline mem set right here? It looks like we're mem setting this location with zeros, and some things are filled in. I wonder if this looks kind of interesting. Let's go back. So we're getting the address of this into var4, and then we're zeroing it out. I don't know why these are being loaded in the loop. I don't know if there's a way for me to move these outside of the loop. Because, like, oh, also, have you seen that you can highlight and it, like, shows you the relevant code when you highlight it? It's really cool. For entry completing it instead of clicking. Oh, interesting. That's nice. So this is var5. This is like, let's put a comment here. Mem setting mem set ox200 with 0 for ox40 bytes, right? Enter accept comment. Bam. So I think that's safe to say that's what it's doing. It's getting the address here. It's zeroing that out. It's, wait, is it going backwards? Is it adding -1? Is it zeroing out before there? var5 -1. Why is it adding -1 to var4? Let's see if we can type this. How do I add a type to this? Can I not set? I can set a type here, I guess. Retype variable. This is let's say a car pointer. Here it's adding -4, so that's actually a list of ints. That's kind of weird. So plus -4. So let's retype this as an uint star. Okay, so it's casting that to uint star, and then it's going back 1. So it's zeroing out the first one, and then it's going back through memory in reverse and zeroing out 40 hex. Let's change the comment. Now, OX40 D words, or 32 uints, starting at OX200, 400, and going back in memory, question mark? So, going back in memory, zeroing that out, okay. Then, while ivar4, let's rename this to, like, II, or let's num uints. So, num uints is 40 plus -1. It'd be kind of cool if I could change this into a minus equals or a minus minus, but whatever. Then we get var5, which is a reference to this. We call these functions, and this is probably where we're going to start running into maybe parameters not being detected correctly. So num uints, what is that? See, this is one thing that I don't like is, okay, so this is an R1. So, and this is R0, I'm guessing. Yeah, so it's passing zeros to both. Then it's calling all these. I'm curious if one of these is like jumping to main or something, and then it maybe will come back out, and this might be, I'm guessing returning up from this is probably fatal. So this is copy. Oh, I see. So I'm guessing if it's not equal to copy, then that means it probably will like initially set up the firmware here. So this is probably init, and this is if you've already run once, then it goes to this location. Shit, I don't have that dump anywhere. I don't have that memory location in any of my dumps, HCI comms. What's the hotkey for rename? It is L. So just L, rename function, rename local or global. It works for all of them, it seems. And then retype is control L. So that's tough because I might not, since I don't have this memory, I don't know where this is going to. But I'm guessing this is probably this is only being run if it's not initialized. Otherwise it comes to here and this is the way out. Although this returns out, which is interesting. So this is called with zeros. Let's see if anything... Hopefully we can start getting some functions. I'm gonna get some like quick functions figured out. 2EE. 192. 192K, is that the size of any region? There's 288K of SRAM. So that's not necessarily something I know. Divided by that times 10,000. Is this like a loading address? 2EE. Divided by 32 hex. Divided by 50. Where does that pointer come from? The one at the very end where it's trying to go to. This one, I have no idea. So... what about these? I'm trying to see if like any of these look meaty. This one looks good. This one's dereffing this address, OX200 A08. And this should be a pointer, right? The way I see it is that's dereffing it and calling it. But it's possible that this is just the function itself. Calls it with this. This does a BXR1. R1 is the loaded address from there. Okay, so that's branching to that location. And I think this code deref is probably how it behaves when this is not defined as a function. So let's make this into a function. And now let's go back. So it found those bytes correctly, but it didn't name it as a function. And now that works. Okay, cool. So when you see the code, deref code asterisk, that looks like that's probably when it is trying to call something as if it's a function, but it has not detected it to be a function. So here we DSB, serialization, we return out some parameter. Ghidra has problems with the thunk stuff. I mean, at least it identifies it as code, because the thing I've noticed with Ghidra is it like doesn't necessarily get the locals perfect and like all the structures, and sometimes thunks it has issues with. However, it looks like the what am I trying to say? It looks like they do a much better job of detecting code in the first place. Like here, it found this like very tiny snippet, but it did correctly mark it as a function. Yeah. So this is interesting. We're setting an A here. And then down here, if this is equal to 2, then we set A here. This is just, is that a global? Yeah, it's writing that out. So, get some stack stuff. I'm curious if there's any like parameter parsing or something, like boot args. I mean, this is probably a custom OS or like a one-off firmware OS, so I'm not really sure. It's so good at finding code. It's nuts. I don't understand. Unrecovered jump table. I've never seen this before, so this looks like it's struggling with a jump table. data, these data things. This guy. I'm looking for something that looks like it's going to a main entry point. What are these things? I have no idea what this function is doing. Is this like floating point stuff? Is this soft float maybe? Because it looks like it's working with a bunch of magic constants and doing a lot of math. Some shifts. It's shifting by 31. This could be, maybe this is a 64-bit divide or some floating, soft float stuff. So, jump table stuff. Okay, so at this point, we don't really know where this is going. So I'm just going to maybe find, let's see if we can find, there aren't really any strings. Interrupt. Well, this is nice. So this is a good place to start. I love finding format strings because you know this is being passed to sprintf or printf. And I can immediately start learning a little bit and start getting some like standard library things named, and other things are probably going to be local, like other libc things are probably going to be local to this string. So let's find references to this. We're going here. So this is the guy. This is clearly a printf. 1, 2, 3, 4 args. 1, 2, 3. It found 3 args, not all 4, but that's fine. So we know that this like is some global, but we know that this is like det cal. Oh wait, this one is det cal. That's probably gonna complain. Oh, it automatically renamed it. This one is num. I mean, that's a terrible name, but det cal. That's interesting. I unnamed detcal, and this seems to... There we go. Huh. I don't know why it's not happy with that. And then this one is, let's say like total. And then this, we'll call this printf. It's probably not sprintf, because I don't see a string. Let's take a look. This looks like VSN printf. One of these is probably VSN printf. Is this sprintf here with a gigantic buffer? This is VSN printf. Maybe. So here, this is a character. How do I... So like one thing I'm interested in, this 2a here. 2a is not... So why is that saying it's null, right? It's saying that it's 2a decimal 42, and the character representation of 2a is null? I'm guessing, this is probably a 4-byte compare, and it probably only takes the first character. Maybe? Yeah, because it's treating that. Let's see if we can find. Comparing with this. Let's see if I change it here. The SN printf with -1. Woo. Nice. So we want this to be character sequence star. So that fixed it up over here. So what was the hotkey for that? Function. Wait, where is that at? References, colors. All right, I'm on this. How did I get there? Where the hell was I? Convert into... So I would have to add some... Go to instruction info. Oh, that's pretty cool. Oh, that's really cool. Wow. Delay slot depth. Man, this is fantastic. Result objects. It has all of the like flag effects there. Wow, that's really cool. Dynamic update. I wonder what that does. Probably like refreshes it as you I can probably have that up as I go to different instructions. Yeah. So you could just have this up on another screen or monitor or something. Computed call. Wow, that's really cool. That is really cool. Okay, so how am I gonna hotkey these? These are clearly, this is, let's find other things that use this. This looks like it's writing to a stack local, maybe? How much space does it make on the stack? 40 bytes? Like, this is clearly printf or VSN printf or vprintf, because it takes one arg. It's going through, it's treating those as uint pointers, which makes sense. Yeah. Yeah, this is so sweet. Yeah, I'm trying to figure out if which printf this is. I'm just gonna call it VSN printf because I think that's usually what it distills down to. But this might also just be vprintf. F4 is supposed to be a bind hotkey. So this is writing to stack of this. This might just be vprintf. Let's go, and this one, what does this take? We got parm1, parm2, 3. They're being passed here as a bunch of args, so it's constructing multiple args to this. This is like an internal. And this one, let's see how this one's invoked. Xrefs, oops, I don't know what I just did. Isn't it Control-Shift-R? Control-Shift-F. And it seems like sometimes it doesn't work. There we go. So we've got a couple invocations of that. This parm2. This looks like that's the format string. Is this VSN printf? And then let's go up to this one, see what references this. Here. This looks like VS printf, not an actual VSN printf, because this is going to be parm2. Parm1 is the string. 4 is probably some stack local. pvar2 plus 4. This is probably malloc, I would guess. pvar2. This might be like a malloc-like thing, or get data, looking at this, dealing with a bunch of offsets, filling things in. Ooh, I don't want to call it yet. Oh, I see, it's just not bound by the compiler, okay. So let's try and see if this looks like a malloc. Because this looks like the buffer that it's using. It's doing something. It gets a pointer. It then null checks it. And if it's null, then that's kind of a weird behavior for null. So let's take a look at this function. Find references to this. Yeah, this looks very malloc-y. Let's just go to a couple of them. This, it grabs something, it null terminates it. This one, it allocates 2 bytes, 3 bytes. This, it null checks. Like this looks like malloc. 100%. So let's keep looking for refs. And let's find where it cleanly then passes it to another function. So this might be like a mem set, right? Parm1 plus 4. So this is probably a free maybe. Let's look around. So once I kind of find something that looks malloc-y, I like to start poking around and try to find the free routine, because once I have malloc and free, I'm in good business. And this is probably like a printf. Whoa, this is something. I don't know what that is. You think it's not a byte count? It's like an element count. Looks like malloc into here. Let's find a clean one. So this Alex 30, and then it calls this for 30. var1. I think this is B0. This looks like a vectorized zeroing. This looks like B0. BCM DHT doesn't free ever. Oh my god. So let's give some types to some of these. I don't know what I just did. Undo, save, retype. We'll call this a car pointer. All other parameters, yes. And then this one we'll call a size T. Yeah, that is what I wanted. Whoa, that was wrong. Car pointer. There we go. So then we have this. I just want to see how good this like vectorized thing looks. B0. This is the probably number of bytes, and this is a pointer. Don't retype. Edit function signature. Yeah, this is nice, but I mean you can retype them separately. I don't know. I haven't had a huge issue. I think when you retype one, it commits the whole thing as is. Let's see. Why are these undefined 4? Pointer. I think it looks like it's dereffing it as, so this is the if there is greater than 20 hex bytes remaining, then we do 20 hex bytes at a time using store word, and then down here we do more bytes at a time, and yeah, roll out until eventually we end up just doing byte at a time, which is probably this one. If you edit the types directly, it doesn't propagate? What? It says so in the manual? Weird, okay. Let's, where's my control Z? Why? I have no more undos. I have no undos. Okay. Don't retype. he's like, the stream delay is killing me. Yeah, this is just like a normal B0. Looks great. So this is not callic directly. Let's find things that use B0. So this, find refs, stop. Let's find things that call B0. Why did that not work? Find refs. Yeah, this is cool. That's definitely B0. Yeah, I can just set the function signature. That's what I did, I think, yesterday. I was just using IDA ways. This is kind of cool. You see the ones 3C. What's this? B0100. I'm trying to find other standard like libc routines. Things that look pretty libc-like. Looking for anything that looks like a memset or a memcopy. This right here, this looks like memcopy right here, right? We're passing in a 9-byte string, we're passing in a 9. And then we look in this and we'll see some like unrolled stuff and then a -20, and this is memcopy. So, I mean, it's possible that could be stir n copy, but I don't think so. Yeah, it's not. UI looks so much better on Windows than Mac. Yeah, I don't know. So this is on like Swing on a Linux box that doesn't have like a good window manager setup. But so that's cool. So if we look at this, we should see this in memory is. Look up at the functions. They should be in a row. You're saying like the mem copies, all the libcs are probably local. I don't know how to look at the functions in order. I guess I could look here. Let's just scroll up to the function before. This is, I don't know what that is. 7C and a thing. Actually, I think I scrolled out of memcopy. Oh, we'll go into memcopy, then go to the one before. So there's vsprintf, memcopy. All right, let's play a game. What is this routine? If it's 0, then it zeroes out some global. Yeah, that doesn't look libc-like. I should enable dark mode. Where's dark mode? Oh, that's probably in, I'm guessing, in configure. What is it? Ooh, look at all these plugins. It's kind of cool. Yeah, where's that dark mode at? Quite frankly, I don't like dark mode, so I don't even want it. But yeah, if I look at the functions list, functions. So memcopy is here, and if we go here, that's kind of what I was doing, but manually. I don't know. This doesn't look very libc-like. What about this one? This one. While this, if this in one is 0, not quite. Oh, it's in my tool settings. Cool. I don't know. These don't look particularly libc-like. Especially with let's go up from memcopy. Memcopy vsn printf. This. Yeah, a lot of things could be inlined. Dark modes are overrated. It's easier to read with the contrast. But yeah, these, I don't think it looks like these are necessarily in order. They probably did some pretty crazy stuff during their build that just was like optimized everything. So let's look at other things. Ooh, that looked good. That looked really familiar. Number of bytes, B0. What else can we pick up here? This looks... If we look at strings, maybe we can find another... oh, PC equals. What's this? Who uses this? Stir compare, stir copy, stir something. Okay, it's a lot more than that. Parm1. Oh, this could be Sterlen. I don't know what this is. They seem to have this like everywhere. So we get a thing from here. While this is not equal to 0, we call this on it. Plus equals 1, or while it's FF. Is this flash if it's looking for FF? Let's find, let's go back to malloc. Can I do that? Looks like malloc. Hell yeah. We're gonna call this malloc. I think we're safe. Yeah, that's some trap handler. So let's look at the call tree for this guy. This will be kind of fun. Show call trees. So outgoing functions, this is what malloc calls. Yeah, these are like offsets for... this looks kind of metadata-y. Enable interrupts? Do they disable interrupts during here? Maybe they don't have locks and they just have like a linear allocator. I wouldn't be surprised. This would actually be pretty easy to reverse out this allocator. It looks really simple. Doesn't really stand out to me as a specific allocator, but okay, so here are things that call it. P of R4, P of R4, P of R1, and then 8. What would it... So it's passing this in with the length. This function... A lot of globals. Is this multi-core? Is Ghidra multi-core? I don't... I think Ghidra is, but is this processor multi-core? I don't think so. I think it's fully just an RTOS with a single core. Yeah, definitely malloc there. This cog tree thing is so fucking cool. iParm1. Sadly, there aren't many like string things. What is... Let's see if we can find the let's see if we can find the handler for, or maybe we can find some of these like E5 or one of these. I don't know if this is my MAC address, but this is probably close. We could probably search for this. I don't know how to do a hex search. Edit. I just want to search. Navigation. Search. Next instruction. Next bookmark. Next label. Search for memory. I want to search for... let's see how this works. 0022. So that's doing Indianness swap. So if there are no spaces, it does the Indianness swap. If you don't, then... So we'll do the first part. Not found. Hex. Loaded block. Search all. Next. That's a pretty fast search. I don't think the MAC address would be in a different ordering, but we could try it. Just get rid of the spaces. And let's look at it. Whoa, it found that. That's definitely a MAC address. And this one is a slightly different one. Okay. So then, wow, look at this. You can pick the like scoping, the alignment requirements, the endianness. This is really cool. Okay, so dismiss. So this looks like a MAC address. Now, I don't know if this is a MAC address that happens to be here due to a packet. Let's do some more searching, sorry. Search for, that was S. Ooh, did it not keep that? Okay. So search for this, next. So it only found one. That's really cool, because that means we can now make a label here, and we can call this MAC address. And let's turn this into, clear that, clear this, turn this into a an array of 6 elements. Is that right? Oh, fuck, I think I did the wrong offset. We want to start at... So this is 0022. Okay, so I guess they store them as words. So this is the MAC address, but let's see some of these xrefs. Let's make this labeled. Where did that label go? Oh, it's way up here. And there are a lot of xrefs to this. This is cool. So... I'm learning the hotkeys, sorry. Is that MAC a global ID? So let's... There are a lot of things that reference this, and almost all of them read from it, but maybe we can find one that writes to it. Not quite. Not quite. According to this, nothing writes to it, but maybe it's a complex usage chain. So here's something that gets your MAC address. This, what is this? These are not, these are some magic things. Does anyone know what these are? Is this like encoding for Bluetooth packets? Is this like channeling stuff? Nothing on that. 83848D96. Bluetooth. That's not working. Okay. Because this looks like some sort of encoding or decoding. I'm not sure if this is like channel hopping related math. I have no idea. Is it a divide? I would have expected if it's a divide, I would have seen the, You know what? I don't actually know if this processor supports divides. Optimize divide or multiply? Yeah, but those constants are easily Googled. But, I mean, it is putting stuff up here. So let's see what else we have. This one, that's an address. Oh, so here's something that is fun. I think we can probably make a filter. Create a column filter. Context. Let's see. So like some of these are just data. So I think if we could say context does not contain data, maybe? Is that a thing? I mean, this is overkill because in this case we don't enter a valid string data. Okay, apply filter. So that was that, and does not contain. Apply filter. Yeah, so like you can filter out things based on like, oh, I don't care about where that address is referenced. I only care about where it's actually being used. That's really cool. So now we have that filtered down a bit more. I saw one that was kind of interesting. MAC address here. So what's this? What is this? This looks like, I bet var6 is going to be a broadcast out. This is memset, I'm pretty sure. It's going to be writing these things out in bulk and these out in bulk. And var6, if we look, will be var5, which will be shifted by 16, which will be this shifted by 8. So it's taking the byte and making a 16-bit representation of the bytes flattened out. So this is memset. Dude, the fact that this is so easily readable that I can just like eyeball that's memset is... This is nuts. This is crazy. This guy. This is taking a MAC address in a 6, which looks like a mem copy. This could be a different mem copy. That is definitely mem copy there. I'm pretty sure that's mem copy. So this might be another mem copy. Actually, this is picking up another arg. bparm4. That's just a local. That's not ever used. That is incorrect. So let's just do this. I like every single time I look at this decompilation output, I'm like floored. I like go flying back into my chair. This is free. There's no licensing. You can use this on any machine. It works offline great. You don't need to like... It's insane. Like when I went to renew my IDLE license last year, I no longer could do a named license and I had to switch over to... I did a computer license because I do all my research pretty much on one machine. But it's so hard to like... With the computer license, I can't just install IDA on all my computers. And when I'm doing game reversing, I can't just have IDA open, you know, on my gaming box, because I can't afford to have it on all of my computers. And the floating licenses require a license server, and I have online networks and offline networks and all sorts of things. Like, do you think this is better than IDA Pro? In terms of detecting functions and detecting code, absolutely better than IDA Pro. In terms of disassembly or decompilation readability, I would say it's better than IDA Pro. And then in terms of picking up locals, local naming And SSA stuff seems a little bit worse, or like SSA-like behavior. You know, when EAX is assigned, like EAX has the same name everywhere. But in terms of the readability of this, it isn't riddled with goto statements. It's so nice. Can I demo auto analysis again? Of course I can. I can watch auto analysis all fucking day long. Let's take a look at another binary. Let's go. Let's build something. CD here, make dir test program, CD test. Let's do app source PDF crack. PDF crack is like a really simple PDF like cracking tool, but it's really cool because it's all written in C, and I just use it as like a quick test for a lot of things. So let's do OOG and make, and now we have this, and we'll just add this to this current project. I'm not too worried about it. Test program. So we can grab PDF crack. It detects its little Indian. It's gonna get, this will have all dwarf symbols, which will be kind of fun. But so let's open this up. We'll have a pop under here, analyze, and this is just going, picking everything up, applying function signatures, and there we go, we're done. So if we look at, this is actually RC4, which is kind of gross. RC4, let's find, oh, scanf, I didn't statically link it. Actually, let me statically link this. I think that will be more fun. Oops, let's see, close, PDF crack, don't save. Close this. How do I close this window? Close tool. This tool has changed, don't save. Okay. I was like, I don't know if that's gonna screw me over. Here we'll do static, make clean, make. So hopefully that's built it static. We will pull in a new one. IDA can do an elf. I mean, yeah, we'll bring some binary blobs in, but I just want to show it on like a like supported thing with like statically built with symbols. And then we'll bring up another thing. Actually, I think I intentionally grabbed some like D-Link firmwares, but I don't know if I ever figured out what architecture they were on. Shit, I don't know where I put those. I had some like D-Link firmwares and some other like, I searched for just like router firmware and I found some random router firmwares. Yeah, I don't know where I put those. Oh, actually, I think I know where. They're probably in my downloads folder. Let me see here. My computer, home, downloads, D-Link extracted. Okay, so here, I think this, that's not what I want. I can do better. Maybe this one? Seems to have nested files in it. I've never seen that. Because I think this is the kernel extracted. Pretty sure this was the kernel. What was this? Are these like utilities? No, those are ect things. I feel like this was the kernel. Like I swear I had it working. Was it this? Yeah, I think I had like the VM Linux or something parsed out, but whatever. Anyways, we can just use the Bluetooth one again. Try running it on itself. Okay, so if we import a new one and we go up to home, Bluetooth reversing, we want HCI comms, and this was the ROM, which is the one we care about. Let's grab this, and we'll set the language to ARM v7 little endian, and program name this. We might have to rename it test thing. So we load this up, we grab this. In this case, we want to help it by saying that it's only in thumb mode. This is PDF crack. I'm gonna close this. Is this one? This is the test thing. So now we're going to go and change this to have the processor options, set the thumb bit to 1, and then auto analyze. And we'll put on the one that you recommended, the parameter ID. And here we go. Completely opaque. It's so crazy. Like, how is this possible? Let's see if I can. Let's make sure. I don't know if I have that machine up and running. Let's see. Root manager. Where is my IDA? Is it this one? Run. I'll find out. What's going on here? I don't know where my IDA VM is at, so I can't load up IDA. But like, yeah, this is insane. And it does such a good job. Like, I don't get it. And it's free. So, do you have file validate? File validate. No? Maybe? No, I don't see it. It's in the menu. Yeah, I don't see it. Maybe once it's done analyzing. So, let's see. Alright, that's done. Let's see if we have... No, I don't see it in here. Oh my god, it's so good, dude. Look at this. Like, this is a partial running image of firmware without all of this section. So it's like missing RAM, it's missing scratch space, it's missing some other things, and it's still just slaying it. Like, I don't get it. I just don't get it. It's crazy. Okay, anyways, don't save. Yeah, maybe they took that out. I don't know. Yeah. So, anyways, back to kind of where we were. Looking at references to MAC addresses. This looks like a memcopy, right? If it's less than 3, then we do the bytes individually. Otherwise, we do them in blocks. Like, this is memcopy. They just have another one. This one, let's see if I can do memcopy. You think I can just do this little bad boy? Take this, put it in here. That was not what I wanted. I got a middle mouse button it. Continue editing. Doesn't like const void. Whatever. There we go. Refresh. Okay, so then we can look back at where it was used, and there we have memcopy again. Why is there an asterisk there? Oh, you know what? That is interesting. It seems to want the voids tied to the pointers. That's fine. That's actually the syntax I personally use. So this will hopefully be a little bit better now. Here we go. Oops, this one was it? Yeah, there we go. That makes sense. Yeah, so this is incredible for firmwares. I have noticed it has some issues with like private symbols. I tried it on a couple like Windows components with private symbols, and it did not like it. But same with IDA. When I looked at some like Windows internal things with private symbols, I actually had to report some bugs like earlier this year for IDA to fix. But yeah, I mean, Ghidra's used to reverse things that you'll never get source to ever. So, let's see, what else do we have? We have memcopy here. That's definitely a memcopy. We have something like this. This also kind of looks like it could be a memcopy. Ooh, while true, is this stir n copy? While true, if parm3, is that a dereft thing? If parm3 is not equal to 0, parm3, this... not quite sure. Well, this is returning a difference. Is this... what returns a difference? Memcompare? Is this memcompare? This looks like probably memcompare, because the returning a difference between these and then returning 0 if it makes it to the end of a loop. I'm guessing this is memcompare. Let's look at xrefs to this quickly to kind of confirm that other things look like memcompare here. Control Shift F, find references. This is called all over the place. Let's see if we can find it. If ivar3 is equal to 0, then we do something. Otherwise, if it's less than 0, then this. Otherwise, that. This looks pretty memcompare to me. I'm calling it. I'm calling it. It could be stir n compare, but it's taking in, since they're taking in, Ivar, yeah, I think this is memcompare. It's hard to say. We'll go into it, change the signature, just whack, damn it, damn it. Continue editing. Why are there two clipboards on Linux? It drives me nuts. I actually have this fixed in my Xterm, but since I'm using a custom Xterm for this font for the stream, I don't have some of those things. I keep accidentally doing it. God damn it. Middle mouse button. Memcompare, get rid of the const, because it doesn't seem to like that. Boom. Now we have memcompare. So if we go back up to this, go to here. Like, what's pretty crazy is as you start naming these things, things start clicking and clicking and clicking. Like this could be, you know, once you get some of the libc things filled in, everything starts making sense. I wasn't scrolled on chat, sorry. Yeah, it looks like memcompare. What else do we have? So here, look at this. It like identified correctly that these are stack things that are like 6 bytes in size. That's so fucking cool. Like, maybe it's because I named it memcopy, but the fact that it's able to pick out that these are 6 bytes, I consider really impressive. You know, it doesn't treat that as just a dword or something or just random bytes. Like, it explicitly says that's an array of 6 things. Here it's filling in some stuff. MAC address here. Passing in a MAC address to a function with 4 parameters. I don't know what this could be. Ooh, not sure what that is yet. Did you realize yet that it does global type propagation for function members? You can xref on function members. Ooh, I did not know that. Huh. Man, that's crazy. What else do we have? MAC address, MAC address. I'm trying to find like a stir copy or something, but I don't think, is stir copy usually, stir copy is usually its own thing. It's not a stirlen with I guess we're just not dealing with strings much. Get an address to the MAC address into here. If that's 0, go into here. This is probably another, I think this is another fucking mem copy. Why can't I go into this? Oh, that is not in my, I don't have this in my database, this address. So this might be yet another mem copy. I wouldn't be surprised. So I don't think those are getting inlined. I'm guessing they just have multiple components and based on the patching things and different things. What else do we have? MAC address here. This is probably memset again. Oh, this is, I think, in the scratch space. So these are probably like different things. They probably have like 3 copies of everything. Stir copy is a stern copy -1. Yeah, I could see that. We might not see a stir copy because they just don't have any fucking strings. Like, what are they gonna be stir copying? You know? Oh, that's really cool. When we defined that copy thing as a 4-byte character array, it put it in our string list. That's pretty cool. Unless it was already in there, but I don't think it was. System is up. Here you can see the like addresses line up for the patch, the RAM, and the ROM, which is interesting. So this is probably the version that's being used, and this is probably the like the ROM version that was replaced with a patch. So, what else? TCA not. Yeah, this debug port's interesting. Let's see. I think what I wanted to do is try to land on. I want to see if I can land on. Let's go to Bluetooth thumper. And we'll fix this up at some point. This might be like an ongoing thing of like coloring up this database over time, but I'm just trying to learn how to use Ghidra. So what I could try and do is try to find the ioctl handler for the HCI events. So there's going to be something that's going to read bytes from a serial port that is then going to parse the different types of HCI events and commands. I don't know a good way because none of these are really unique values because they're all bytes. This one, OA5C. So, OA5C. 5C OA, OA5C. That one might be unique enough for us to find. So let's do a search for OA5C. And it'd be really cool if you could do either endian. In this case, we want OA5C in this representation. And we found one. We found another. Oh, this is all over the place. This is not common enough. Let's see if we find that in an instruction. So search next. That's a coincidence. This one is not really legit. This one's not legit. Okay. So is there a way to search like a text search like IDA has where you can search for the program text? Yup. Selected fields. All fields. Search for OAFC. God damn it. Let's see if we can find this. I'm curious how fast this search is. Oh, it's slow. Okay. OAFC, yeah. So I'm guessing we can reduce the state space down of this that search and make it a lot better. Sorry, oops, I docked it over on another screen. Use the program text search is better than memory search. Oops, repeat text search. Program text search. We're looking for instruction operands. OAFC. Oh, in this case, we want FCOA. Oops. I'm using IDA hotkeys. Program search, Control-Shift-E. FCOA. In operands, That's so cool that you can like restrict it to certain things. This is a bit slow. I will say that. But yeah, I'm trying to think. If I search for FCOA as an actual binary pattern, that hopefully will fit in an immediate, so we might be able to pick it up there on an instruction. FCOA, OAFC, OAFC. We're doing it right this time. Okay. Damn it. OAFC. Sorry. This is just my window manager. I'm not used to using GUI apps at all. OAFC, coincidence, coincidence, coincidence. Is this one referenced by anything? It is. That's interesting. This one. This one? FC5. You know what? You know what? This is my command. This is definitely the command I'm sending. Is it? Let me look at the... I think these dumps were done with the C version. HCI comms test.c. So I'm sending... What is the command I'm sending? 01 AFC 0504. Like this is definitely my command I'm sending. 01 OAFC 0504. Yeah. So this is an HCI packet here, and then the 35, and this is like the stuff I construct. This will be the address. So yeah, if you look at this, the address that you see is the address that I'm dumping. So here you see the this address. This will be a pointer. So if we it's a pointer to itself, because when I was linearly scanning through memory, I read, I think, a byte at a time in my tool. So it just happens when it's reading this, this is the command it's using. This is definitely like the this is definitely the buffer used for inbound HCI commands. So we don't see the 01 out front, but I'm not worried about that because the 01 is like a it's a prefix on HCI, if I'm not mistaken. I think that's saying it's like that's the response when I'm constructing it. Oh, I just hard code it. But I think the 1 is saying it's I think that's what indicates that it's an HCI message, and then the raw payload is after it. So this would make sense, and then we just xref this and we win. So there are a bunch of data references to it. There might be like a ring buffer here. I wouldn't be surprised. So let's look at what refs this. Param, this function here takes it in, gets an address to it. We're not seeing that used anywhere. What about here? If you set that to an array, yeah, let's go back to it. So this is probably like maybe a size. FFFF, 0202. I'm trying to figure out if they have like a ring buffer for multiple packets. Let's actually look for this, what we send it. And then we should have an 04 after that, yeah. So I'm gonna quickly go up to the top. It doesn't look like the home key works, which I use a lot in IDA. So OAFC 0504. So we have one. We only have one reference to it. So this is definitely where the packets, these HCI frames are coming in. It's weird that it's unaligned, but whatever. Let's see. That's really cool. So we care about xrefs to this. We also could look up for xrefs to like a more aligned thing, but I don't think so. This looks like what is being xrefed. So we see it put here. We see it put here a bunch of times. Are these pointers as well? Those don't look like pointers. You see, okay, that's just all of these. So this one stands out the most to me because this one is kind of in a unique area. But I don't see any xrefs to this block here. This one. It has one xref. Please be a code xref. It's a data xref. There are a couple. So I don't think this one is the one. So there is a right here. This is what fills it in. Get process stack pointer. This is where it actually fills in the, this is where it fills in that pointer. So this is probably like, uh-oh. Hey, how cool is that? That it doesn't like tear everything down like IDA when you have a single error. So I don't know what the gray is here. I think this is when it like couldn't fully do something, but this is setting up that address. Let's go back. So I don't think you can rename things. This one looks more relevant. What is it? Ghidra has a GTK plus option for the UI. Edit. Tool options. Let's see. Overview tool. Docking windows on top. Oh, that's kind of nice. That might help with things going behind. Edit tool options. Where do you see GTK? And it's so configurable. Scroll wheel pans. Display. I mean, this is the decompiler. Console? I don't know. It's in the project window. Okay. Well, that docking window's on top might be nice. Or it will bite me in the ass. It's in the project window. What's that? What is the project window? Like one of these, or in one of I don't know what the project window is. Oh, in the I know what you're talking about. This one. Configure. Oh, I have to close it. I'm not closing it, but tool options, I'm guessing it's in here. Oh, Eclipse integration? Exactly what I want. Tool, it's in here. Yeah. Maybe, I don't know. Project is the first window it opens. Yeah. Yeah, sorry for the stream delay. Edit tool options. Oh, swing look and feel. Oh, GTK. Oh, there we go. Yeah, so it has to restart, but whatever. I'm fine with this. Like, I don't mind. I care more. When I see a firmware binary being analyzed this well, I can't give two shits about how it looks. I would be fine with this being the R2 command line interface if I had this level of decompilation and disassembly and function detection. Please don't add an R2 interface. Anyways, let's find refs to this structure here. This one writes it in Set process stack pointer. This is like very early initialization. I wonder if this is where it's setting up. If it's not equal to 0, then we double DRF that plus 8. We fill it in with this. ivar 3. So sadly, I can't rename this function, right? Because I get an exception when I try to rename it. Don't go that far. Oh my god. Let me see. Let's see. Apparently, what time is it? Okay. I wonder if I can change. I'm curious if I can change the delay here, and I don't know if I can. Info and settings. Like, I know I had an option for it. Stream optimizations. Ultra low latency for real time. Does not support closed captions in this. Oh, okay. Yeah, I can't change it at this point, sadly. Sorry. R2 isn't that bad. I respect the work they put into it, but every time I've tried to use it, it has always crashed. Can I rename the function from the disassembly? Let me try it. Up here. It's... okay, undefined function. Actually, you know what? This is... You know what? I think the gray screen... the gray screen is probably when this is not a function. Boom. Look at that. Someone probably said that. Someone probably said hit F, you idiot. Whatever. Okay. Holy shit, dude. Every few minutes I need to sit back and realize what I'm working with here. Like, I hope all of you can appreciate how impactful this is going to be. So, I don't know. The R2 team is mostly painful to work with. So, yeah, I don't know. Anyways, this is just nuts, dude. This is nuts. Like, I've lost my train of thought of what I was trying to do. I was trying to figure out where that buffer was coming from. So clearly this is the only spot we've seen our packet pattern is here. So there are a bunch of XREFs to these guys. So let's see if any of these look clean. Data XREF. So this is like a nested structure. So this one references it. What's the nearest XREF on this guy? Up here, maybe? So a lot of people have been wondering why they're open sourcing this. And I truly, I have no idea why. But my viewpoint is they probably realized by open sourcing this tool, they probably doubled the size of capable reverse engineers over the next decade. Like, this will dramatically increase the amount of people who can't afford to get into it. It will increase accessibility for people in countries where you could never even remotely save up $1,000 to buy IDA. It will get people introduced to a tool that NSA will probably be able to now hire for. Like, there's so much here. I don't know. It's just crazy. Like, I can't even reverse engineer with this tool because I want to spend all of my time just looking at how it works. Or, like, just looking at different outputs. Like, I don't even want to do anything. It's crazy. It's just crazy. But, I don't know. I'm really excited for this industry to grow because of the tool being accessible and you know, they're going full open source, which is further than I would have expected them to go. And that's going to they're probably going to fix a bunch of issues, and hopefully they'll accept pull requests that are sane. But so try out binary version analysis. Where the fuck is that at? Oh, binary firmware analysis? Try out the binary version analysis. Binary version analysis. I don't know where I'm going. Oh, binary version analysis. You're talking about like this stuff where you can diff things. This, the like version tracking stuff? Where you're able to like diff, like bin diff shit? Skip, finish. Like where you can do version tracking, and I mean I'm diffing things that aren't really meant to be diffed, but it opens a bunch of windows, which is kind of gross for how I'm set up on the stream. But yeah, this stuff is awesome. I was playing around with this last night. I don't really have anything to bin diff. But yeah. This stuff is nuts. I actually have a pop under window somewhere. Shit, where is it? This one. Would I like to analyze it now? No. So it's probably not going to work when I don't have them analyzed, but I looked at this and yeah, you can do all the confidence and score filtering on all of the like matches. You can do version control, so you can, like, I'm pretty sure this is intended that for like years of a target, years of a firmware, you keep loading the firmware into this, and you don't treat them as separate databases. You keep loading the new firmware in, and you manually track the changes and the diffs, and you update things. And I'm sure they have some nutty databases of like firmwares that they have crazy history of, and they can see all the patches, and they probably annotated which are CVEs and all of that stuff. Click the wand, yeah. I know about the wand. This is probably not going to work because we're comparing things that aren't, well, what are we comparing? We're comparing the, if we compared the RAM, it would actually work pretty well. Let's see. Let me kill this. Close tool. Don't save. So let me load in the this one. This is the ARM v7 little endian. Load this at 200, 123. This. Let's open this up quickly. Hasn't been analyzed. No, we don't want to analyze it yet. We want to then set the processor options, set the thumb bit, save it, and then we'll close this tool. And then I should be able to diff these two, open with version tracking, and it just automatically does that. We want to do 0 to this. So this is the source is the ROM, and this is the RAM. We're going to skip the preconditions because we're just going to have it try. Then I probably have another pop under. If you had a working window manager that had, you know, well, this is fine for me with multiple windows, or with multiple monitors, but it's pretty hard to manage. So yeah, this is going through. It's going to do hashes of all the functions in both the different things. Completed successfully. So this I think is failing because let me analyze that other one. Actually, it might be running. Yeah, I think it's running right now. Let's do close tool. Don't save. I'm going to delete these version tracking databases, and we're going to take... So this one is the one that we have open. So this one should be good. Yeah. So that one is good and analyzed, and then this one, let's get this analyzed. This is only the RAM. I'm curious what it's going to be able to do here. So we set the processor T mode to 1, and let's go. And we'll put on that one option again. I don't think it really matters in this case, but whatever. So this is just the RAM. I don't know what this is going to find. I don't think there's too much code in the RAM. I found a couple functions down here. I don't know. I mean, this looks like it's just filled. Yeah. So there's just not much code in here. See you, Philip. Thanks for joining us. Dragon. Oh, I like that emoji. Nice. Nice. So it's hard to say if this struggled to find things or if there's just really not that much code in the actual the RAM portion of stuff. So what I would want is a different firmware. I would want like 2 versions of a firmware to really showcase this. And I just don't really have a good setup for that. I don't know of any easy firmwares. Like the smaller, like a good 300K firmware would be nice. I could maybe try and get another Broadcom firmware off of another phone, but I don't have another rooted phone. I don't know. Anyways, let's see if we can find. Can I output all of the source? Export program. C++. Output file. Ghidra.c. Options. Match 12,000 functions in 20 minutes. Yeah. Huh. This is pretty cool. So it's going through and decompiling the whole program. IDA has this option as well, but it's ball slow. This is also kind of a small firmware. I think this is 600K-ish. 512K of ROM. So we have this destination file. And now we can load that up. Oops. So this is the whole thing, all 150,000 lines. So what I could do here is maybe I can search. Now I can do like regex searching for that. What was my magic string? We want FCOA. I'm not seeing that. FCOA, OAFC. That's a coincidence. OXAFC. Ooh, what are these? F801. Holy shit, did we just get completely lucky? This F801, that is, I'm pretty sure, that is one of the commands. Compile it. Oh, it builds, and I got a binary identical output firmware image. Holy shit. God, this is so cool. I think we got really lucky here. Let me I think I'm allowed to use the internet, right? I'm allowed to search for things. I'm allowed to search for like Bluetooth FCOA, right? I can Google that. Bluetooth FCOA file type PDF. Yeah, this does look like a command handler. I think we like got completely lucky. Bluetooth BCM 4330. Read RAM. We're just Googling. That's a send command? Yeah. This is output. This is creating a command. Like it totally is. I don't know how we stumbled into this function. But yeah. This is constructing a packet for sure. So let's search for maybe Bluetooth Scratch. RAM. Boy, how do I Google? What am I searching for? I'm searching for like a Bluetooth read RAM spec. Read RAM Bluetooth. Here we go. This looks kind of cool. Oh, this is a CCC thing. Oh, someone's done something on this. This is probably read RAM, write RAM, launch RAM. Yeah. So that's kind of cool. So this is someone like going through and doing stuff, but I don't want to cheat. I want to search for read RAM is what it's called, right? Read RAM. Maybe we'll do Google. Bluetooth file type PDF. What's this? What else do we have? BCM 4330. Here we go. This looks good. What's this? BCM 4330. Oh, cool. I found a document that has things that tell me how to read and write different things. Oh, there's a command that's allows me to read RAM and launch RAM. O4D. Is that right? Launch RAM. Yeah. Yeah, we already got the PDF. You're just catching up. Don't worry. We're just catching up on a 1 minute YouTube delay. Okay, next time I'll make sure I do it real time. So yeah, there's launch RAM and yeah, O4E. So yeah, you can pass it you can pass it a type, you can pass it, or yeah. So if we look at how we do like the read RAM stuff, I actually want I feel like I could get a slightly better document potentially if I Google a bit more. Read RAM. Let's go to Google again, see if this one helps us out here. Not quite. But this is like telling me how to, it's not telling me as much information as I'd like to know about this. But nevertheless, let's name this fucking function. This one is like, oops, sorry. Go to this function. God, I keep using the wrong clipboard. This is like construct some HCI packet. I always like to make sure that I have very little confidence in the naming of my functions until I really understand. But yeah, this is kind of cool. How much you can read, how much you can write, the error codes, enable radio. But yeah, the FC, I think, FC04, is that? I don't know how I convert this into the other one. I've definitely seen different ones with, I've seen some good, BCM 430 spec file type PDF. What else do we have? I'm sure there are some cool things we can learn about this. Maybe I'm just looking for a little bit more info on this chip. And I don't know. Google, dude. Google is nuts. RAM. So this is some block diagram for something that I think is using it. Yeah. But so what we'd want to do is kind of look at read sleep mode parameter. This is interesting. uart. Oh, I wonder if this is it. I wonder if this sleep mode stuff, I might have to send like a wake something to like wake it up, or I might have to configure I might have to set this up and be like, hey, set up my baud rate and set up the syncs for the serial port. Update uart baud rate. So I'm guessing that the device is going to sleep. Write the Bluetooth address. So yeah, there's a lot of cool stuff you can find if you just Google around a bit. So anyways, F801, let's see if we can find an FCO something. FCO. FCO4. I think that's maybe a coincidence. FCO4, yeah, I think that's probably a coincidence. FCO4. Was it FCO4? Was that the one that we were searching for? FCOA. So it's possible that we won't see FCOA. We might see, it might mask it off. And I might do like, XOA. What else can I find that's a little unique here? What about this number? That's a nice number. That might be a good one to search for. Baud rate something? something baud rate? Something. Let's see where this is used. Shit. Whoops. Damn it. Go. Here. No! Watch as someone fails to copy and paste a million times in a row because they keep accidentally using the normal clipboard. And then we have a pop under window. Oh, we're fucked. How are we going to get that window back? There we go. And we highlighted it. The fucking X clipboard is so bad. It's so bad. Alright, so we're in this function. This is like maybe some... where was that document at? This one. Sorry. Yeah. This is like baud rate something. I feel like I have a rename window open. Yup. Baud rate select. Baud rate select, and then we can look at xrefs to this, and then it will just probably tell us exactly where it is. And this will be something that will get a var1. We'll pass it into this function. It'll probably divide by it. By parm3. Yup, it divides by that. And it does some shifts. And it's doing all the logic. It's dividing by 2. Yup. And yeah, that looks pretty good. Can you turn off the extra... I know there is a way to turn it off. I just don't think I've configured... Oh, here we go. Broadcom debug port. So this is probably... I bet this is initialize uart. Calling it. And then this is write to uart. Do you think this is used in a bunch of places? Well, that's a string. That's taking a... Oh, we'll probably get a we'll probably find this. This is probably output uart, right? Uart. Is this gonna get some like weird? Yeah, it's getting this 3.6. This is probably the MMIO space for the uart, because it's writing to it. This is gonna be like write byte uart. I guarantee it. Write byte uart. A what? What do you mean, a what? Find references to this. We'll find a couple. We'll probably find one that takes, so that writes a 4. This is definitely writing to the UART. Write to UART this. Write byte UART. So what's this? This is going to be like a string of something. This will be a null terminated string at $$pound. So this is do while ivar1 is not equal to 0. This is like write string, or this is like while this is not equal to 0. While ivar1 is not, while the return. What the fuck is this? It like keeps trying to write a byte while it's failing or something? It was apparently delayed by 5 minutes. Uh-oh. Uh-oh. While that... I'm trying to find one that is... Oh, that's an AT command. Oh, the... Oh, we'll go back to it. I'm sorry. We'll get back. This is an AT command right here. Is this send AT command maybe? The AT command. He's getting so excited. Yeah. This is pretty good. This is pretty fucking good. This is oh, what is this? What is this? This is if it's less than 10, we add 30. This is converting into a if it's less than 6, then add 37. Cuz this is adding 0. If it's less than 10, then we add character 0. And let's change that to a character 0, which is a convert to this. And this is a 7. Okay, so this is takes in an argument. If it's less than 10, then we add 0. So this is this ATOI or ITOA maybe? This is like convert to digit or something. Let's go up one function. Something convert to digit. And then we'll go up. Dude, this is fucking nuts. Okay, this is used all over the place. Yeah, and then it's var2. Where is that first reference? Where's the one that we cared about? It does this a lot. So this one? This one is converting this, and then it writes that, and this is, takes in an argument, shifts it by 4. This converts it to hex. This is this takes in a byte, and then it outputs the hex string representation. This is byte to hex digits. Oh my god, dude. I don't even know, man. Like, I can't even explain the feelings I'm having right now. Yeah, convert to hex. It's okay, you'll catch up. We're talking like 5 minutes past each other. I'm so sorry, man. I'm so sorry. I don't think I can change it live. I can insert an ad. Yeah, fuck ads, dude. No ads. Ingestion settings. This is pretty good. Let's see. Convert to... I'm trying to look through the options I have here. No longer editable for the ingestion settings. The thumbnails. We can still change the thumbnail at least. Great. So... is it hex or octal? Honestly, it could be octal. But the thing that's throwing me off here is the shift 4 and the and F. Why would it be passing an and F and then a shifted 4? Here, if it's less than 10, it just adds 0. If the parameter minus 10 is less than 6, then it adds 7, which will make it an A through F, I think. Capital A through F. Because if we look at an ASCII table quick, let's bring this foreground. Man, ASCII. I think we'll see that if we add 7 to 0, fuck, where are we at? I think this is just, yeah, there we go. So we have, oh, this is kind of a weird format. Okay, table. So we have the 0 through 9, and then it's gonna add 7 if param1 minus 10 is less than 6. So it will add 16, so 7. It's the different. It's definitely hex. It's definitely hex. So byte to hex digits. So that's pretty cool. This is probably used in a lot of places. Oh my god, this is so cool. Yeah, this is used here, and it like passes in. This is another parameter. It's taken like 30, 14. Oh, it's so cool, dude. It's so cool. And we can clean this up. Let's clean this function up. We're going to go into here, and we're going to apply a better prototype here. We're going to edit the signature of this function. We know this is a character output. In fact, let's be more specific, and let's say this is a 2-byte character array, and this is a single character, and this is the digit. This is I don't know, the digit or something. Oh yeah, we'll absolutely check. I make more mistakes when reversing than I probably make 90%, 95% mistakes when reversing. And I saw that 7. That add with 7, and I'm like, oh, that seems kind of octally. So it's always good to think of those things. And this is like output. I think that should work, right? PUVAR3 is that output to, we might have to change it. We'll just change this to a pointer, sorry. We'll just do this. Yeah. So output 0, output 1. That cleaned up nice. And then if we go back to this function, hopefully we don't see crazy casts anymore. Well, I guess this makes sense that it is casting because in this case it has to. And then 1, yeah, 1, 3, 5, 7. So it's clearly expecting 2 bytes from each. It returns 4. We might be able to see like a MAC address here. If we find a loop with 6 like this, like a loop with 6, and then we'll probably insert a colon in here maybe. This is probably converting a MAC address to a string. Output equals that. This is parameter plus 1. We set it the first thing to D, and then we grab the MAC address here. Yep, this is output equals output plus 2, which is param1. This is get string MAC address. Can you publish yesterday live? I'll have to look. I just haven't had time. So actually, you know, the last part of that video is unlisted. Let me get that for you. The first part that was recorded on Twitch, I was banned, so that disappeared. I think I have a local copy saved, so I might be able to re-upload the first part as a part 1. But let me quickly find you the link for this. Because it's currently an unlisted video. Fuck, even I can't find it. I might have to go to my, like, my channel, where is it? I know some people on Twitter had a link floating around for it. Shit, where is it? Where's that unlisted video? Let me search unlisted, maybe, hopefully I can find, yeah, see this unlisted, and this, and here, and this, and paste. So that is the second half. I got banned, I was streaming writing cheats for MapleStory. So, I mean, it's fair. I'm not complaining at all. Well, go get some go get some pizza. Go get some pizza, come back. Ghidra's not going anywhere. Ghidra's not going anywhere. Man, this is so cool. Holy shit. This is nuts. Like, we're churning. We're making good progress. Anyways, let's go back to, these right to uarts I want this. Give me. Oh, so here it converts something to hex digits, and then it writes that out to the uart, and then it optionally writes out, like, I don't know what that was about. I feel like I'm actually able to work. Like, I feel like I've got a decent workflow that I've learned already, which is pretty awesome for Ghidra. Okay, so while this write to uart this, so let's see if we can get local to this. Let's go into write byte. Let's try and find the read byte from uart. How should verify was a feature? Yeah. So we probably care about anything. This is probably getting a status register, and then it's probably checking if it's probably checking a status register. So anything in this region, this is probably all to do with uart stuff. This is probably their uart is at 360. Let's go here. What's this? If this is less than 0, shift 1F. Let's just do a little look-see. 003600, and then we can do dat under. So this is probably resetting the uart, I'm guessing. Let's take a quick jump to here. This is 6cc. Let's call this maybe reset uart, because it just puts Fs into all of these fields. And this is probably, that is loading up 140 into those. One of these is probably going to load up the, like a uart buffer or something. Has that 90s government software feel. That's probably just because I have a shitty skin on Linux and it's like all default swing stuff. So in this case, this looks like, not sure. This is configuring the uart. This is configuring the uart for sure. Oh, this is like configure uart, and it like has to be. It has to be. This is latching in all the settings. That's resetting the uart again. This is doing some stuff. I'm looking for something that reads. Oh, this is checking. I want something that like loops. This looks good. We do a function. If it's not equal to 0, then we do something. While the parm, I'm guessing this is read bytes from uart. This is waiting. While it's not equal to that, then return this is something. Yeah. I don't know. I like the feel. I feel like I'm using a tool that has been entirely engineered for hacking and working, than a tool that's been designed to look pretty and make sales. And I think that's really cool. This is probably like maybe read from uart, and then we'll just put in these little xrefy boys. Let's look up at how people use this. Case 2, 3. What's this? Some data buffer slash. Let's make this a string, little stringy boy. This is how do I make this a string? Right, string. Did that not work? Oh, I might have to undefine it. If they data string. Clear. Oh, maybe I have to highlight them. String. Okay. Does that look like anything to anyone? Does string look like anything? Oh, it looks like it's using the first 4 bytes. I'm guessing this is read into this. Local 30, I bet, is a 4-byte array. I'm guessing this is reading from the uart, the number of bytes you provide it. Let's see if we can find some other uses of it. They might be all in this function. Case 8, grab that. Local 30, pass that as a location. Wish the menu bars would render at the top system bar on iOS, or on OS X, sorry. You need to set the length or highlight it. Yep. Oh, what else can we do? Let's keep looking through here for other uart looking things. This is, I don't know what that looks like. This looks like, this might be probing if data is ready on the uart or something. That might be waiting for uart data. This is get a character and put it in here and then update the array. I like this. 2, 3, 4. Let's see, this is like also maybe read from uart, because this is while uvar1, which is II, is less than parm2. This is oops, what did I do? Undo. No problem. This is number of bytes. UXTB. iparm1. This is going to be, let's make this a quick little a character pointer. Output. God, that cleans up so good. So I think this is reading. Let's see if this 1C is used. 3601C. It's used there. It sets it. Checks it. It reads something. You gotta get more monitors. This setup I have here is a 6-monitor setup, so limiting down to 1 screen for the stream is killing me. But I actually have like the xrefs window. You're not seeing me go through the xrefs window because I have that up on this monitor. There are actually no xrefs to this function apparently. This is just like dead code, maybe. Okay. That looks pretty good. 36001C. While it's not equal to 0. This is another one that looks like it's maybe reading uart stuff. 3425E. Let's see if there are xrefs to this. There are. This is like also maybe read uart. This could also be reading a status register or something. Also maybe read uart. What does this pass? This passes that. That passes a 1. This is probably a buffer. This passes 3. If data is equal to 3, then it does this. What's this? What does this look like? What do some of these buffers look like? FCOA? Wait, what? Aren't we looking for FCOA? Aren't we looking for FCOA? I'm pretty sure that's what we're looking for. FCOA. 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 Am I going crazy here? Is this the one, dude? I think this is it. And then it ends it with FFF. I think this is it, dude. Looks like this reads the command ID and length. And then it goes into here. It passes this as an arg, and it ends it with this. This is going to look up in a table of the different supported opcodes. It's looking up ushorts in here. Let's do a cast on this. This is probably a cast, and then it looks up at this address for probably a dispatch routine. This is probably where it dispatches it, do you think? FFF, FFF1, C8. 46F. Yeah, all the different types of comments are great. I love it. I'm a big fan. FA. Okay, what is this doing? It is taking ivar1, which is this. So we're going to say this is II. It's going to look up this. And this is going to be command ID. Whoops. My bad. Uh-oh. Command ID ushort. This is like maybe like look up command handler. And then let's just go up to xrefs on this quick, and we should see just a couple. So here we see one. And here we also see one. And let's see what it does with the return value of this. Wait, where did that go? Look up command handler, look up command handler. What? I'm trying to go back to where we were. Sorry. Here we go. This returns a PUVAR4. Let's take a look at. This is definitely the like serial command handler. We got an allocation here. Look up command handler. We get this PUVAR4. And then we call this function, which +2. I feel like that's BL this +2. No, I have an xrefs window off screen, but you can have like multiple references open, which is nice. Yeah, sorry. I have to have a somewhat usable environment. So I'm guessing this function, let's see what's it complaining on here. I think it's trying to decode that explicitly as, cause it's a +2. Let's clear these bytes. Let's go into this. And let's explicitly disassemble as thumb. Bada bing. Create a function. What was create a function? That is F. Okay, now we go up. All right. So this takes in this parameter puvar4 prim1, which is used to, if it's not equal to 0, and this is some stuff. Then we grab prim1 here. I'm looking for like a function pointer. Function, not quite. Yeah, so I think what happened there is since it was +2 on the instruction, I think it, yeah, I don't actually know what happened there. But I don't know. I mean, it was easily resolved, so I can't say I care too much. This is going through, maybe this is looking for the function dispatches. Looking up stuff. Prim1, prim2, uart4, while this, doing some stuff. Get out of that. Oh, this is probably disable interrupts. Yeah, disable interrupts, enable interrupts. So let's see. And this is probably a little bit more specific. Actually, did I fuck that up? This is get current interrupt mask. So, and then this is cur int mask. So this is just saving and restoring the interrupt mask. Yeah. I think this only can have thumb, and it saw that it was directly trying to call into something, and it probably, since it was a non-odd address, yeah. Literally typing it out as I'm saying it. Yep, that was my guess. We're on the same page. Okay. So, this is cool. That's like disable. Like, we're getting cleaner and cleaner and cleaner. Like, these things, having these little helpers will just get better and better. That's one thing I love about reverse engineering is as you fill things in, they start to fill in other places, and then things start making sense. Like where we saw the MAC address. We were in the function that wrote out the MAC address as a hex string to the uart, but we didn't know we were in there because we didn't know the uart port. Like, we knew it was doing something with the MAC address, but then when we revisit that function, it was so much clearer. Like that, the clarity and the epiphanies that come from reverse engineering, I just love. This is interesting. It like disables interrupts to set this flag, and then it re-enables. Getting used to the delay. That's good. Look up command handler. So I'm gonna use the restroom quick. I'll be right back, and we'll try and find the dispatch. So I'm guessing it's probably gonna be like a function pointer or something that it does dispatch on, and hopefully we can find. My goal is to find the routine that is the FCOA handler or whatever, the one that reads memory, and we can hopefully see it like directly reading memory and seeing how that works. So I'll be back in 2 seconds. Sorry. All right, I'm back. Sorry about that. So let's do a little bit more thorough reversing of some of these routines. Man, this is so cool. I'm glad I had the. This is why I like to work with raw firmware dumps rather than I like to deal with firmware dumps that was in a live state rather than dumping or grabbing firmware binaries or something before they're loaded, because everything's fixed up, all patches are applied. You know, you can see, like, we were able to get this far because we had the oracle of some of the command strings that we were sending it. But, oh my god, this is so cool. So this gets yeah, if this, 3, do we pass it do we send it a 3? No, we send it a 1. We send that, and then here, FC05. And that's what we were seeing in here, right? FCOA. That's probably just a... Oh, yeah, that's what it was. FCOA right there. This is nuts. Okay, so we read into here, then we have this command handler. We're then going to go through with this command ID. If it's not equal to FFF, if it is equal to that, we return null. Otherwise, we go to this data section, and we're indexing this as... I don't know what the type is on this. This, I'm guessing... Let me look at the assembly quick. Load half word, and then we increment II by 1. So this is LSL by offset that. So this should be an array of it's an array of words, I'm guessing. So I'm going to say it's 10 for now, which is wrong. Oops. And we broke it. Undo. Literally just undo it. Let's see. Function data. Let's set this to a. Let's set this to a. Is it a word? Do you think? Is a word a 2 byte? Let's see what happens. Okay. Then we'll do data, create array. We'll do just 16. Oop. Maybe we'll do 10. Actually, let's choose data type. Word, okay. Data, create array, 10. So it's going through... And this is going while II is less than 3. Oh, okay, I didn't see that bound. So 1, 2, 3. So if it's one of those, otherwise it returns 0. So in this case, we should be returning 0 from this function because we didn't match on any of those. So let's look at xrefs to this. Let's see if this is used in other places. And it looks like it is. Control-Shift-F, this. It's used a lot. So here's where it's written. In a couple different places. Actually, let's name that. I don't know why we didn't name that field. My bad. This is the, like, command. Let's call this command ID buffer. So then we'll look at other things. I refresh that. Command ID buffer. So now we can quickly look through things that set it. Command ID buffer is CO3. Command ID buffer is this or this. I wonder if these are outbound. Are these the responses? FCOA, no. Oh, it's possible. So let's look at where it reads it. here. Somewhere in this function. Command ID buffer. Where is this? Why am I not synced up? Command ID buffer. It reads 1 byte into that. It then looks up in this function. Oh, here it is. Here it's figuring out the type of command. Right? This is looking at the first byte. This is like command type. Oh, this is so fucking cool. I don't see the FC. iPerm1, let's highlight that. FC. Okay, let's go up. So we read that 1 byte, and then I'm guessing we then store this. Where do we use that? If we grab this, if it's not equal to 4, this. Do something with the command ID buffer. That's part 1. If it's equal to that. The decompile looks wrong. For what? Sorry, we're kind of like out of sync at this point. Command ID buffer. So here it's filling in 501. Like 5. I'm guessing this is the like output construction. This is like constructing a response. Command type. I'm waiting for that epiphany of clarity. This is probably copying out the bytes. This is the buffer that's going to be used to send. This is probably the response. If we go to this. This is probably the response packet that it sends back. OAFC 05. It's close. This one, read uart, look up command. What else do we have? 55 OFAA. The big weird switch one. I don't remember where that was. Sorry. Is it this? I mean, this looks like it's processing different things. So a switch. Can Ghidra fix the stream delay? Do you want me to fix the stream delay? I could probably kill the stream and restart it without a delay. I don't think that... I think that would be probably fine. Let's see. Yeah, so this one, I'm curious if this is switching on... What is in this? What is that this? 0. Switching on this. If it's 0, this might be an operating mode. This is like probably handle. Yeah, I don't want to mess up the VOD. Sorry. Next time I won't make this mistake. It's definitely constructing packets. Let's see where this is called. Let's go up the stack. Let's look at the function tree. References. That was the wrong one. Call trees. So this A 801, where is this coming from? Do a while you are enabled or something, while this is 0, or like this is like handle uart traffic. And this is probably like it's a fucking while true. And then in this is probably like some, on an interval we do this. And on this, we pass the same thing into both. What is this function? Some sort of a copy. Man, they disable interrupts all the time. So reset and 8162. Yeah, this is definitely a state machine. So, I mean, we found a like uart handling loop. So it's hard to say what this is. I'm trying to see if this looks like anything sane. Oh, you think this is an auto-generated state machine? Like they didn't actually write this code? Like they use some spec or something. This is a handle uart command, probably. You know, it's good when you're starting to say probably instead of maybe. You know, it's just one level above. What's this? I'm just trying to see if we can pick up any anything easy. Disable, enable interrupt stuff. Given the amount of, here, let's do this. Auto create structure. Thank you. And this one, auto create structure. God, that's so cool, dude. Oh my God. Let's go up. Ooh, I like this. I like this a lot. I like this a lot. This looks like a reset that's 0. So we call this function, we like did some uart stuff. We're calling this in a loop. This is probably like get you or like check for uart or something, or maybe this does all the processing. And then this looks like a function call. This is probably like if we have a command to run, or maybe this is a hook, invoke this function. So we could maybe see where this gets sourced from. Let's xref this guy quick. We're gonna call this some function pointer. This find xrefs. I only see read locations. I don't see where that's getting assigned, which is kind of sad, frustrating. Some function pointer here. Okay, so if there's a function pointer, then we invoke that. Otherwise, we go through here. We don't know what local 28 is. This is like probably at this pointer or something huge. Yeah. Local 28, we call this. Hey, the Vulcanizer shirt, dope. Hell yeah. I don't actually know who you are. And you don't have to respond if you don't want to tell me. Given you have a Vulcanizer shirt, I know you're one of 20 to 30 people. Let's see. UART stuff. Disable interrupts. Working with data. You want me to auto-generate some structures? We'll auto-generate structures all day. Look at that. Oh, that's kind of fun. That's putting a function pointer in there to this. A lot of function pointers. Let's see. I'm guessing you're yeah, sounds good. data, less than that. So let's see, what do I want to do? Actually, you know what I can do? I can go to this window, references, call trees, here, and let's add a filter for uart. How do you like that? This tells me all the ways I can get to uart things. Oh, that's so amazing. So it's like, okay, you're in this function. That function calls this here, which then goes into here, which then goes into here, which then goes into here, which then calls initialize uart. So we probably don't care about this. This is probably like early init stuff. Then we can look. Okay, actually that is. This might be. Everything's nested under this, so this is like handle uart maybe. Let's actually we don't want that. Handle uart traffic internal. Did you like this? Oh. Oh, this I'm gonna be using this a lot. Okay, so now we're in this function. We know that everything nested under here, we only see the read uarts in this function. So like these are the things we care about. So we're in this read traffic. We want to go into this. And this is probably there's actually a do while here. Let's see the bounds of that do while. It's huge. This is an infinite loop. We have an infinite loop here, so this might be handling all traffic. Disable interrupts, set something, maybe this is saying like ready to receive or something. We do a switch on this, which 0. If it's 0, then we call this function with a 5. If that is 0 and that is 0, we call this, which is this. I'm just trying to explore around like what shape of things look like before I start naming things. No, I think that was a fair reaction. I think that was completely legit. So case 0, which is the current state of things. This is a while in a while in a while in a while. There were 3 at the main root function. Here, read uart. Also maybe read uart. God, this is nuts. Command ID buffer, passing that in. It's ending with FFFC, which is, I think, case 1. Case 1. I'm curious if case 1 is this. I think that's the first byte, maybe. Let's see. Where does this come from? Who xrefs this? And does it come from a serial port? And if it does, then then I think we're in business. This is written to here. It's written to 4. Here it's written to some data +1. Let's go back. Okay, so if we look at case 0, let's assume we're in case 1. Case 1. Like the switch statements are so clean. So case 1 is this, and in case 1, if something is 2, otherwise we do this. We read the command ID buffer. Here it's doing some stuff with var5, which I think is... This is probably... I'm not sure, but I think this might be the case that we care about. If it's 2... Let me go into here. We're getting more. We're doing something on the command ID buffer, which is here. This is returning a deref of, wait, what was this? and that is BBB, then we return that. Otherwise, we return 0. So we're not sending the BBB command. I don't know what that is. So if that is equal to 0, and this is, let's see, and if this is equal to this, function local 30 0. Otherwise, this is memcopy the command ID buffer into this. So this is, we're gonna call that copy of sometimes, because it's possible that like this is not always used for the same storage. Here we allocate something. We take var5, which is this, which is command ID buffer. Let's see. I think a thunk is just a function without a stack frame. I could be wrong. Or a function without like a... Oh, yeah, how would I define that? Without a stack frame, maybe something that doesn't return, something that jumps over to a different location. So instead of BXLRing to return out, maybe it jumps to a different target. So that's kind of what I would consider a thunk. But I guess I've never thought about that. Like what is technically a thunk? What's this? Were we here? That is the BBB. That is 1E. It might have already masked it. What does this look like? That B7, not quite. Oh, we're getting close. Copy of commands, buffer, and FFF. What else do we have? Other stuff down here. Here we read, this is case 2. We read more from the uart. This is what we looked at before. If it's 0, if it's 1, if it's 7, read uart. This, get this plus this, it's AA, 5 F data, function, copy of command buffer sometimes. Function here plus -4, not quite. That's doing some stuff. Oh, whoa, what's this? What's this? What's this? This. We grab pyvar3 is the deref of this. What? If it's not equal to 0. Wait, what? If it's not equal to 0, and then here, this will never happen. That's kind of interesting. Where's that? Initial branch non-zero, go around. Oh, this is really cool. So I'm not quite convinced yet. I do think we will have interrupts disabled where we are. Is this a pointer to a function? No. FDO3. I wonder if I'm looking for the wrong data. It might be masking stuff off and shifting stuff and rotating fields. Copy of command idea. Sometimes, here we go. This guy and FFFC. This guy does some stuff here. Not quite sure yet. This one actually adds 1 to that, which is interesting. It grabs this and adds 1. Okay, so that's probably updating state. Yeah, this does look like a big-ass state machine. 3OD to 307. Copy that. We fill it in with 0 at the end, and then we're done. Copy of command ID buffer sometimes. Here we go. If it's equal to 0. Is there symbolic value search? I'm not sure. Search for matching instructions, direct references, instruction patterns for scalars. Like, this is so powerful. Program text. Don't see it here. Direct references. Scalars. That's... Oh, you can search for ranges? Oh my god. You can't do this to me. It's so nice. It's so nice. This is the function we were in. We might have to start naming some of these. Just so we get a little bit more idea of what's going on. So this is checking if deref is equal... wait, is this a linked list? Is this a, like, flink? If the, like, backlink, dereffing this parameter, it's like maybe flink blink. List deref. I don't really care if I'm right or wrong with that. I just want to start applying names to things so I stop jumping or looking into functions that I've already looked at. But this looks kind of linked listy. Wait, what's this? C-O-L-B, Colb. Colby. This one takes iparam1, ands this with FFC. Like, this looks like some sort of a dispatch handler, dividing it down. This is like looking up an index into some list of shit. Are these pointers to functions? 6408. 303. Oh, you're ready, dude. You're ready. You'll fire it up. You'll slay it. It'll be good. This is looking up something. So that's doing... Like, I'm looking for either a gigantic switch statement, or there's going to be a function dispatch, and I'm not quite sure which one I expect yet. This one's doing some, like, field rotation in... Let's start in... Oh, fuck. Let's do this. Let's do this. Let's do this. That might behave strange. Up. 3OD 307. Not feeling anything on that yet. Maybe linked list. Like, I could totally see this being going through a linked list and looking for handlers, and if there is, then it calls this on here. PIVR3 is equal to this. A deref of this. Sometimes a function pointer, maybe dispatch. That's a nice name. Okay, so PPI-var4, if it's equal to that, then it's 0. Otherwise, it's this, which is this. Fills that in. So if it's not equal to 0, if it is 0, then we zero it out. Otherwise, we deref some stuff. Yeah, we deref this. Who fills this in? I'm wondering if these are, like, this guy maybe fills that in. One of these. one of this one maybe. I'm curious if one of these sub functions fills it in. There's a FFC. That's not ringing anything to me. Is it free? Maybe? Maybe? Like, it looks kind of like free because it's going backwards on a structure. Like here. I was kind of suspecting that when I saw this looks like metadata stuff, and then we saw this that's going backwards on this, going backwards on a pointer, which is really rare. Like, you get it on Flink Blinks, and then this is linking shit up. This is probably free. I think you're right. Thank you. Thank you so much. If it failed, this is maybe like an assertion or a panic or something, or like check whatever. Yeah, I think this is free. I think this is free right here. Let's see where it's called. Show call trees. Incoming references. Maybe free is called in all over the place. And then let's see where that lines up. Oops. Maybe free is this. This might be. What's the alloc that does a copy? Maybe free. Maybe free. This definitely looks like cleanup code. Things that are like clearing things out. Yeah, it 4-byte aligns it. Maybe free, maybe free. Like, this looks like a destructor, doesn't it? Doesn't this look like a destructor? Oh, yeah, look at this. Please come from the malloc. Please come from the malloc. That is coming from... Well, it's checking if it's 0. If it's 0, then it returns, and then at the end, let's see where this is set. This is written to here. Is this the only spot? This is the only spot I know of it being written to. But after it frees it, it zeroes it out. Like, I'm pretty sure that's free. It's possible that one of these could be a realloc. Yeah. I'm not sure. Nevertheless, I'm pretty sure that's free. So this is, if it's BBB, then we return this, which is clearly being used. FA pathfinding functionality, like how to get from where to where. Yeah, there probably is. There's probably, I mean, we can do like this. Well, that's function graph. We don't want function graph. We want, function call graph. Right? Like this sort of thing. And then we can, I'm guessing, like, get the child, yeah. Malloc, maybe free, memcopy. So we have like this sort of stuff, the edges and stuff. But yeah, this expands out and you're able to see all of these things. So this is pretty neat. But I mean, IDA can do this with their view. They have a similar view. I mean, this is definitely constructing like an outbound packet. And I have function A and B, find me the code flow. Scoped flow? All flows too? What's that? What's that do? All flows too. all dead subroutines, program highlight, scope flow, forward scope flow. Backgraphs. What happens if you right click on the background of the graph view? Any options? Of that graph view, which one? I'm guessing you mean the function call graph. Just some docking things. I don't see navigation tool options. That's just that. Yeah, this doesn't look very configurable. But I mean, you can kind of approximate it by all flows to as like colorization. Yeah, I think so. I think it allows you to like, so what's this? If I want to do forward instruction slice, okay, backward instruction slice, highlight def use. Locals, comments, find use as a character, forward slice, backward slice. Okay. Huh. Copy of that. Sometimes from here, which is from here. What's this? Yeah. If that, return this. Switch this. Switch this. 5. Length of remaining bytes, maybe. Switch the number of bytes, maybe? Case, where's default? Let's see default. Case 5. What? What is it doing here? Move R04. Store that into here. Get for this in FF. Command ID buffer CO3. This is like making the response. I think CO3, I think that's the F, I think is the vendor thing. So we might want to search for COA. This might just give it to us, COA. Ooh, look, CO3. Oh, look at this. What's this? And that is not equal to that. So this is taking for sure. This is taking your command ID. And it's filtering to make sure it's not a vendor-specific command. So in this case, 3C262. So let's go check for non-vendor command. So this is, if that is not equal to FCOO, so this, we just want to go up from this. This will get us real close. I know hotkeys. This is called in one spot, which is here. Check for non-vendor command. That took an argument, didn't it? This took a refresh, maybe? What is this? R1. So here's, okay, here it's grabbing, it's getting the, so if we looked at the Bluetooth spec, if anyone is familiar with the Bluetooth spec, so I forget what these things are called, the top part and the low part. I might have this referenced in here. Bytes event. So this, the FCOO, it's masking off the top part, and the command that we're using is, of course, an FCOA. So this is getting and FCOO with this. If it's equal to 4, we want it equal to FC, right? So this is doing something. Where is R0 sourced? R0 is from here. Load, and this I think is the argument. I don't know why that's not getting propagated through. This looks like the, so this is this local 18 deref of this. Switch FE. Oop, 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 oop. Okay. Can perform a memory search using a regex. That's awesome. So my guess is it's not actually going to have the FCOA, because the FC gets masked off. So so this is going to tell you the type. If it's not equal to 20, then we check if it's non-vendor command, and then those have some go-tos that get us out of here. This, if that is equal to reset or that, then we go into here. We take local 43. This is the command type. And then this is the, like, I don't know what this is, high command type. There's a name for this, the top part of the field with FC masked off. So if the high command type, otherwise this is referenced here. If that or that, if it's equal to 0, then we come down here, and this is probably the dispatch. If the, yep, command ID, shit, my bad. Edit function signature, command ID. So if the command ID and FCOO, which we have, is equal to FCOO, which it is, then uvar1 is equal to 7. And then we take uvar1 plus this. This is probably a pointer. This is looking it up. This is looking up the dispatch routine. Go to this. Wait, what? Is there no address there? Go to this. 28B 1A. Is that out of range? 28B 1A8. 28B 1A8. Because then it gets this, and it's going to return this out. Fuck. Man, that's not in my database. Oh, that's frustrating. Where's that at? 1 second, sorry, just checking a message. Here's the top of the loop and do select forward scope flow to highlight the end of the loop. Cool. So uvar1 is 7, and we're taking 7 plus this, and we're dereffing that byte and the command ID and that. So this is telling me that, like, the maximum allowed command, and then this is returning something like, yeah, this is like look up command dispatch for sure. Because if we go into this, it is looking for this. If it's the FCOO bank, then it goes into the 7, and then in that case we get the command ID and 3FF, so we get the remaining part of the code, and we look up the, this is going to look up the allowed bytes, I'm guessing, and then ivar2, this is going to be, the pointer to all of the dispatch routines for all the commands, and then here it indexes it by 4, and it derefs this var2. How is this not in my database? This is where the dispatches are. Fuck. I think we have to get this dumper working. I have to see what this is. This is absolutely where it's doing it, and then it calls it. It then calls this routine. And this is probably a reference to the like shit. Oh, how big is my... I wonder if this is like the patch databases here. So like the 1A0 is the valid command numbers, and 1A8, this is the pointer to the list of dispatches. Holy shit. E90D. Okay. Well, I guess we're back to the start of the stream. Where is my ADB session? We've come full circle. See, this is why I wanted to have the tool up and ready. Can you get other refs to it? Maybe there's an initializer for it, even though you don't have it. Yeah. Let me take a quick look for this. In fact, this was kind of nice. Let's search for this. Oops. We want to look for 28B1. 28B1. So we have this, which I think is what we're in right now. We have this, which is dereffing it. Yeah, we only have a couple refs to that. But yeah, this is definitely the yeah, so this is looking up the command types, the different Bluetooth command types, and this would give us dispatch to all the things. And what we would if I can get my read-write tool working, then what we should be able to do is add our own like ioctls into this and make custom handlers and custom commands that we can send it. So we could write in some shellcode and write some custom commands, maybe to like dump register state. So I would like to be able to snapshot this target on a packet. So one of the, it's kind of weird to say, but I would say one of my specialties is writing debuggers and writing snapshot tools where I have no debuggers. Can we show off a binary blob loading one more time? Yeah, of course, dude. I'll load binary blobs all day long. Actually, this was a bad one. Oh, cool. It shows you like your running tools. That's dope. I didn't see that. Table view. Ooh, look at that. That table view's nice. Nice. Look at that. That is sweet. I like that. That's a lot nicer than tree view. This is what I want. Okay. Let's get some binary tools. What do we want? What do we want? FCOO from that address? No. So FCOO is that is the command ID mask. This is really common. You see this all over the Bluetooth spec. Now, one thing that I maybe could try is get rid of the 2 and see if I can find like an unpatched version of it. So find it in RAM. No, it's definitely not that. So, oops. I brought up my, there we go. Okay, so we want to load something up. So let's do something fun. So let's see if I can find this on Reddit. So on Mr. Robot, they had some like let's APC firmware Mr. Robot. I think I might have. I like posted one of the. There was a screen cap where they were using R2 in Mr. Robot that I found the firmware for, and I'm curious if I can find it again. Search function tables. What is that? What's search function tables? Search. Where do you see that? Where do you see function tables? Am I blind? Address tables? I see address tables. This is okay. Okay. This is cool. This is really cool. Wow. Wow. I don't know if you had a function specific one. Matching instructions, direct references, instruction patterns. Yeah, okay, address tables. Cool. Yeah, this is amazing. 5, alignment 4, skip length 0. Finish searching entire program. And we have a couple things. Are these nearby? Let's see. I'm going to do some pokes around. So this one's saying here, here. Not quite. This one, not quite. Yeah. Oh, he found my Reddit history. Yeah. Hell yeah. Okay, so we're gonna make a quick tangent. Thank you, Doug Pants McGee, or Dog Pants McGee. My bad. Yeah, so I was able to find this firmware, and the firmware image was from here. So this was like a screen cap of Mr. Robot. So in Mr. Robot, they had like this R2 session up, and I was like, oh, I want to reproduce it. So I went and found this firmware, and then I ran the same commands, and sure enough, you get the same thing. So let's grab this firmware. Shit, did I have to register? I wonder if I made an account to do this. UPS, unless it was one of these. Product name, software upgrades. What was it? What did I say? I wanted AP9630. AP9630, submit. And wow, what are these things? Management card, firmware update. Is it this? Maybe? Is this it? HW05 AOS 650. That's close. It's close. I just want to see what this looks like. AOS 640. Might have to go back. Try again. Resend. There's an address table one shot if you didn't run it. Yeah. Firmware upgrades. How did I find this? How did I find this? AP9630. Maybe it's this. Maybe we can extract this. Of course I can't open up a fucking folder. Yup. CD downloads. Bin walk. Bin walk. We want EM on whatever I just downloaded. APC. That looks good. Where did that go? Actually, where the fuck did that go? Extracted. Failed to 7-zip. Zip archive data at, this is what I want. 6E75. Oh, that wasn't there. Okay, there we go. So we've got this 650 bin that we'll open up. We'll take a quick look at it. So this, I think this is x86. There's a way to open, here we go. We'll just move that off screen for a second. We will add, we'll go to home, downloads, this guy, and this one. Select file. Let's say it is x86 in little endian. I'm going to hazard to say it's probably GCC. I can't remember if it was 64-bit or not. We could look at the photo quick. But let's see what happens here. Let's see if it can find anything. The dragon. Yes. Analyze. What can you find? What can you find? It's hunting. It didn't look like it did too. Okay, it didn't do great. Let me look at that screenshot again. Where did I put that? So it is definitely 32-bit, and I opened HW05 AOS650.bin 32C24. Let's see if I can go there. Not quite. I wonder if this is like, I don't think it's 64-bit. Let's just start marking some shit as code, see what happens. And analysis. This looks Poppy, yes, that doesn't look valid. CLI, CLD doesn't look too valid. Unless this is a different architecture, I'm not sure. I don't know. Let's see what other bins we had. Close tool. We'll insert. What else do we have? A bootmon. x86 default. Is there a default for x86? No. GCC. Let's try this one. Oh, is this an exe? No. Click. What are we doing? We're showing off Ghidra right now, but we do have an actual thing we're reversing. Let's see if this picks anything up. No, it didn't. Yeah. Okay. Anyways, let's go back to what we were doing. Sorry. Derailed. Possible address table. Where did I put it? It's here. We were trying to find some auto analysis ASMR. I mean, it was, like the screenshot is definitely x86, and it's not 64-bit. So unless the 650 is a different version or something, or maybe I extracted it wrong, or maybe it's compressed or something. I don't fucking know. Anyways, let's get this. Let's start making some. Okay. All right, we got the Bluetooth thumper. We got ADB shell, CD data local temp, BT dump. And I've got this mouse over here. So I just need to get lucky. I just need a couple bytes. I don't need a lot. Swipe up to unlock. It's kind of hard to swipe up to unlock an Android device when it's a mouse. In fact, I don't know if this is possible. Okay, drop drag that down. Android is pretty unusable with a mouse. I can't unlock it. God damn it. How do you swipe up to unlock? Alright, swipe from icon for camera. This is busted. I'm gonna have to reboot it. 1 second. Sevens, it failed. 640 bin, yeah, but I don't know. I don't know. We could look at the bin diff result again, or the whatever we did. 1 second. I'm waiting for this to come back up. Yeah, we don't have 7-zip, I don't think. Yeah, but I mean, I was able to unzip that pretty well, right? CD, CD. Anyways, I'm waiting for this to boot up. We're gonna see if we can get anything going. Oh, ordered some fruit snacks off Amazon. Gonna have some good fruit snacks. Delicious. Wait, what? Can you actually do that? Is that a real command? I feel like you're gonna try and steal my Android device. Probably hacking. Let's try your little swipe command. Let's see what happens here. I'm calling BS. No dice. No dice. Not Welch's fruit snacks. It's what did I buy? Let me see. I don't know. My friend got me, or my friend got some and shared some with me, and they were delicious. I forget what they are. Dude, instruction pattern search? Yeah, I know, it's nuts. It's crazy. I mean, clearly it's written for ROP. Like, clearly it's written for ROP. Like, you could do some pretty nutty things. Like, yeah, dude. Yep. How do I unlock this device? Maybe if I unplug my mouse and plug it back in, will that do it? We'll put it in a different port, maybe. Oh, now the mouse isn't working. Uh-oh. Did it freeze? Let's see if the probably didn't work because the resolution is different. Yeah. Oh, I ran it. Oh no. Oh no. I got hacked. I got hacked. Is this A.out? Is this still a thing? Yeah. ADB push A.out data local temp moose dot chmod plus x moose dot sys moose. Okay, so that's having the same issues. Oh. What happens if I just cat dev random dev ttys2? Maybe that'll wake it up a bit, you know? Put it in a good state, and that well that did a thing. Let's see if I have any help here. HCI formats. SRE16. Paired protocol stack. Patch RAM code. This that put it in a weird state. Oh, did that panic? I think I panicked my fucking device. Yeah, we gotta we gotta reboot it, boys. Hey, you know, I was feeling it. Where do I have a root console? Maybe over here. Here. I can do, screen, dev TTY USB 0115200. There we go. So now I can do an ADB shell. Was that fucked? Is that not booting? No, that's booting. It's just taking its time. It's fine. It's just a little kernel panic. It happens all the time. It's Android. It's Android. Just ignore this. None of this matters. It's fine. It's just some stuff that happens. It's standard things. Stuff happens. Alright, let's see if I can click around. I can't use my mouse yet. Can't use my mouse yet. Why can't I use the mouse? Whatever. ADB shell. What? ADB. ADB kill server. Is this guy okay? Is this guy okay? I don't know why I can't ADB shell into this anymore. Let's yep, and shoop. That's a high-speed device. There we go. Okay, we're in, boys. We're in. Okay, so we want to BT dump. Unless that's killing it, let me see. That seems fine. And if I do, oh shit. It was going for a bit. It was going for a bit. Mad scientist left on point. Oh god. Let's just maybe let this wait a bit. EXD gram socket. Maybe it's just, let's see if I can get the Bluetooth Mac and spam this with packets. Maybe the device is like sleeping because it has nothing to do. If I spam it some packets, maybe that will wake it up and I'll be able to do some hacking. Where's my Bluetooth dongle? There it is. Ah, shit, I'm out of USB ports. Oh boy, where's this going? Where is this going? we now have Bluetooth. Let me restart the Bluetooth system. Bluetooth start AD. We're in. We're in. On a read device, that works. We're just gonna start sending commands. This one? What about 7? What about 9? 10? 12? 11? 0? 1? 2? 3? 4? 5? 6? Hey, I like 6. 6 is good. Is 6 the trick? Or was it... that killed Bluetooth. What about 6? Wait, no permission to enable Bluetooth quietly. Does this enable Bluetooth, maybe? What about 8? I think... 6, 1, 2, 3, 4. 4. Here, we'll kill this, and we'll see if we can get Bluetooth to come up with 8. PSA, PS rep blue, kill. Oh, Bluetooth's not running. So let's find how we can get that started. Yeah, sometimes you just gotta hit buttons, you know? Sometimes you just gotta hit buttons. PS. I think that brought it up. Yeah, that did. And 8, does that kill it? 6 enables Bluetooth, 8 turns it off. Boom. So let's see. So I think what we want to do, we can't have that running. So 6 turns it off, 8 turns it on, was it? 6 turns it on? 6 turned it on, now it's running. Now we can do this, now let's turn it off. Nope. Okay, we can try the other way. We can try it off, this running, and turn it on. Okay, that was good. That's good. Panic info. Okay, yeah. So it's panicking. That's good. So the 8 to 6 transition seems good. Okay, so let's go to HCI Maybe we can use this one. I think this one's okay. Looks good. Probe, read byte. Looks good at that. CD, this one, main.rs, and what we want is, I'm gonna comment these out, and we want data local temp. This is hiram.bin. And let's see where we were in Ghidra. What were we looking for? Come on, go back. Search around. Oh, sorry, you guys are off screen. Look up command dispatch. Find refs. Where did I put my ref window? It's over here. This calls it this. Lookup command. We need this 28B1A0. 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 28B1A. Actually, let's just do 200 maybe. It's not much. Let's just see if we can ever get that. Let's see. The Twitch part I think I have saved. I might be able to upload that. I'll have to check the other computer that I streamed that one from. Okay, make. So we have this shit. How did I fix this? How did I fix this? You know what? You know what? We're doing it. We're making this work. We're gonna get a fucking build environment working. Because now we actually have a reason for this. Android 24. Whoa. What is this path? That's what we touch. Home, Bluetooth reversing, Android, NDK. This platform's Android 24. MIPS, ARC, MIPS. User lib. And we're just gonna make, we're gonna touch rt.a, pthread.a, util.a. Son of a bitch. Cannot find LRT. Why is that? Why is that? Isn't it just gonna look for... What is it gonna search for when it does that? It's gonna look for... like... libm. Oh, it's looking for lib. Yeah, sorry. librT.a, lib pthread, lib util. File not recognized. That's fine. We can do that. We can make it hack. ls. Oops. ls on this. Copy. We just need. How do we make an empty .a file? I'm gonna make a valid .a file that's empty. MIPS, CD Bluetooth. Sorry, I know this font is bad, but we're gonna be out of here in a second. CD, we're gonna go Android NDK, toolchains, MIPSL, pre-built this, CD bin, vim, foobar.a, vim, test.c. Int ASDF. Good. /mipsl gcc. C test.co test.o. And then we can archive, right? Is AR? AR. We want to AR. Test.a, test.o. What? Mipsl AR. Test.a, test.o. What? I'm trying to make an empty file such that I'm trying to make an empty .a file that I can link with because I'm trying. The build toolchain, so Rust cannot build for Android MIPS. So I'm using a Linux MIPS build, and with Linux MIPS it tries to bring in like pthread and some other things that are not supported. Let's see, why can't I... Do I not understand how to do fucking an archive file? Isn't it just that? Invalid option E. What do you mean invalid option E? Delete files from the archive. All right, let's Google it. Make .a file from .o. GCC dev null. Is that gonna work? GCC dev null. Yeah. So then how do I make that into a .a file? Make static lib Linux. Why do I not know how to make a fucking static library? RCS lib. It still tries to link against them as no standard, because I am no standard in this case. Null.o. Libfoo, there we go. CP libfoo. Home pleb Android NDK. Oops, Android. Let's grab this path. That's not what I want. I want, where's my other terminal? This one. CP from, here, we'll just put this in home. Null libfoo. So now we can do CP home libfoo .a to, I want librt.a. Wait, didn't I call it libfoo? Libfoo.a. Oh, why did I do tilde and then home? And then why did I do that? librt.a. Okay. librt.a and libutil.a and libpthread. Please fucking work. Yes. Yes. Did that get some stuff out of it? Cargo. So now we can actually modify the Rust code. We just run make and it will automatically deploy it and run it on the target, which is good. So l/hiram. So then we want to switch this to 6 and is that not working? So let's send this an 8. Bring up Bluetooth. So let's see the normal RAM one. Dump range, libc write, clone skip, lseek end. What time is it? It is 2:30 in the morning. Okay, and then we drop this to 6. No dice. Bring this back up. Wait for the Bluetooth logo to come up. Oh, we're hacking. Oh, we're hacking. Bluetooth is up, so I now can run this. I then can kill this. I can't quite figure out what is going on here. So this one, let's try hiram, and then it eventually fails. Assertion failed. Pointer is equal to an event. So let's see. This prints on index rangelen % read bytes. Let's see. Print we read bytes. Six, 8, 6. There we go. So I think we had 1 byte. What is this? We read bytes and then we print. So it read 1. So it was successfully able to read at this address. Are you using tmux to multiplex? No. This is my window manager. So you're seeing like 3 separate terminals here. So, okay, now we need to get rid of this. This assertion on event. Assert it's equal to this. If pointer 0 is not equal HEI packet type event as U8, what can I do here? Do I just return? Return error failed to read bytes. Saying that you're hacking necessary? Oh, absolutely. You can't hack without saying you're hacking. You crazy? So, I forgot that this tool, I intentionally designed it that it would append, so it will be, it will pick up where it left off, because as you see, it's very flaky. So hopefully this is more resilient. 8. And I'm struggling to get more than like a couple bytes at a time. But we can make this work. But what's interesting is this definitely confirms that there is memory at this address. We were at bytes 6. That takes it down. 8 brings it back up. So where are you all from? We've got a lot of people. I'm guessing you guys probably aren't all, or not you guys, y'all. Trying to not say you guys. Where are y'all tuning in from? I'm guessing I'm no longer hitting much of a US crowd anymore. So, come on. Just give me some more bytes. Where did I start dumping? I started dumping at 1AO. So let's make sure. So we open a file for append. We create it write only 644. We seek to the end. We skip cur off. So we start there. If index, we're just gonna always print this. We'll put this up here. This will tell me the address I'm at. Set your terminal to green on black. Interestingly, green on black is when I type, when I launch a new Xterm thing, my muscle memory types FG green, VG black, because that's how I used to work. There are just a lot of incompatibilities there with, there are a lot of incompatibilities with some like applications that use like nice prints or colored prints. So here from Live Overflow, that's awesome. Thank you so much. Live Overflow is so nice to have tweeted out my stuff. He is I remember, geez, talking with Live Overflow like 5 or 6 years ago. When he first started making videos, I think he was in one of the channels I was on IRC and asking if people wanted like CTF YouTube videos. I don't know if he was making them at that point or if he was planning on making them, but oh man, this is so slow. Let's get this more reliable. I know it wasn't this slow when I dumped it, so let's see if we can get a good chunk going. We read bytes. I just want this to spew. I want this to go crazy. Enable Bluetooth. we probably can't enable Bluetooth while we're listening. So let's get Bluetooth up and running. I'm going to wait for the Bluetooth icon to show up. From Italy with love. Oh man, it's so cool that I can reach a completely global community. The power of the internet is nuts. I think 6 actually launches Bluetooth. We read bytes. How do I... Like, I know at one point I was able to get this to work very cleanly. And I don't understand why I can't replicate that. Let's see, so this is without anything running. There has to be a command to initialize the device. Let's go look at that PDF we had open earlier. What do we want? I want to search for... I might still have it open up here. Let's see if we can send a command to initialize this device. Write BD adder. Oh, did my stream cut out for a second there? Kind of glitched out for me. Sorry. I hope you guys are still connected up. So update baud rate. Changes the baud rate the uart transport communicates. Will be generated at the previous baud rate. If the command complete event indicates success, the uart transport will then shift to the new baud rate. Hardware register by the following formula. Use encoded form, explicit baud rate. Let's see how hard it is for me to construct this. This should be... what is the read RAM? Read RAM is 4D, which is not what I'm using. This is different. I'm gonna try and find the manual that I have. 1 second. Sheesh, where would I have that? C. Backup pre-Linux. C dev. C Bluetooth. Unzip ldev.zip. Unzip h. Unzip dash ldev.zip. Grab blue. And there we go. I want Bluetooth docs. Unzip dev .zip Bluetooth Bluetooth docs dev blue. Only not matched. Dev Bluetooth Bluetooth docs. Okay. And now I just need to go to this file. Yeah, I know you guys can't see it, sorry. We need to go here. And I think this one. No. This one, no. This one. No. Let me Google, let's just search for, this, and, yeah, I'm interested in this, Bluetooth functionality here that I Googled. Okay, cool, this looks really interesting. Read RAM. Cool. Oh, wait, is it this one? Your interface, PCM interface. Yeah, here we go. Here's the FCOA. And here are the different regions of memory you can read. So you can So the FCO command the FCOA command that I'm using allows me to access RF registers, and it allows me to access the actual ARM memory. So I have never looked around at the other stuff, but I'm sure they've got some cool things. So if we look at my code, we'll see that I'm sending an FCOA here, and then I'm sending a 4, which is ARM memory peak. So this is the command I'm using, the super peak poke. But let's take a look at other things. TX test, connectionless transmit test, modulation type. There's some cool things you can do here. TX power level, return parameters, write receive only, download mini driver, command triggers the device to reboot into a state where it can download a mini driver, write RAM. This command writes data into the ARM's 32-bit address space or EEPROM. Then when you're in download mode, you can give it an address of where to start executing from. So launch RAM indicates the address, FFF. Firmware should reboot into Bluetooth mode using that configuration data. Jumps to the target address in thumb mode. Yeah, jumps to the target address in thumb mode. It's just a, a little command that you can send it. Write the BD address, edit the BD address. SCO int param. Fill method loopback mode. Where else do I want to be? I'm looking for something that lets me like initialize the device. Oh, whoops, that was not what I wanted. IRSSI with green text. Yeah, that sounds pretty accurate. Sleep mode. Do you think it's in sleep mode? How do I turn off sleep mode? Oh, what's this? Power management. Set sleep mode. No sleep mode. FC27. We're just gonna send this and see if we get lucky. FN set sleep mode self. So set sleep mode none, and we will construct a request, and we're going to extend from slice 01 FC. This command is FC27, and it takes 1 byte parameter. Oh, this is power managers. Is this the number of bytes here? FCOA. Right? Was it FCOA? Yeah, FC. FC05, FC27. FC27. Then we want to write a. This is probably the length of the command. Yeah, this is the length of the command, which, let's say 1 byte, and we're gonna send it a 0 for no sleep mode. Idle threshold. Oh, I might need a bunch more fields. Wake mode. Resume timeout. Break to host. Sleep mode parameter. Then it returns a error code based on Bluetooth success. So let's try. Let's see what happens if we grab this code here, and we go down here, and bt.set sleep mode none. And then here we'll go Bluetooth jumper, make response not found. Yep, let's grab this. E5. 8 times bytes, not found in the scope. Bytes is 8 times 1, maybe. And not found in the scope. Bytes for that in bytes. I don't think we need that. That expected this, so the result back Q8. We'll actually return. We don't need to return anything from this function. And then local temp. No thrust. So it's not responding at all. We're writing. Wait, what? How are we writing that command? Request as pointer, request out len. Oh, maybe I have a bug in my stuff. Let's see. Print sending request. What? Why am I not seeing a print? I'm really confused why I'm not seeing that print. Maybe this has been working the whole time, and I just have like an allocator bug, maybe? Maybe my print's wrong. Request not in the scope. We'll do this. Print set buff. Print launching. Interesting. That's good. That's good. I like to see that. Then here, this. Oops. We actually wanted to add that in a different location. How did you dump the firmware? I dumped it with this program here, which communicates to the Bluetooth chipset via the uart. So that's what we're sending. And then if we strace this, this is saying, yeah, we should be sending 127 FCO1. Fill the right request. Response.capacity. Set len bread. Am I going crazy? Is this strace wrong? Text file busy. Yeah. I don't know how it's sending something different. Request as pointer. Is that going out of scope? Let me see. For some reason that's... I don't know why. OX41. So there's an A and 27. I think this strace is just broken, maybe. What is 27? What? What if I get rid of these nulls and OX42, OX41, OX1, OX43? I'm really confused. I don't know if this strace is lying to me or not. Oh my god. This is, I was sending the message as not bytes. That might fix everything. Okay, that looks a lot better. Let's get rid of this sleep mode stuff. What is 27? Okay. I think that is a pretty big bug. That hopefully we're good now. Maybe we can actually see it dump stuff. We still might have to play around with these modes. We read bytes. Okay. 8. That should kill it. I was hoping it was that easy. So that looks much better. 108 FC. Okay. So hopefully we'll be able to get this to work now. I think that starts Bluetooth. I'm just gonna wait for it to launch. Unless I started the wrong one. Maybe this is the one that starts it. There you go. So Bluetooth is up and running. Run this. And it looks like we're still hanging. Oh, in that case we weren't. Red bytes. We got 2 bytes. And then Bluetooth died. How did it compile though? So I wasn't pushing bytes, so I just happened to only use non-U8s. Well, actually in this case it should be pushing U8s. In this case it forces that they're U8s. In the other one that I copied, it wasn't. So yeah, this actually has made no difference. But we can see... Bluetooth's dying when we do this, and if we look at maybe a dmessage or logcat, let's see how this is dying. This is probably failing pretty hard. Sigabort. Unknown HCI message type. So it's trying to read an HCI event here. Oh, here. Userial vendor opening. TTY S2. So then we're doing we got an FD open, userial vendor, run thread. Yeah. Command complete event with no matching command, FCOA, FCOA. So this is reading my commands. So I think what we want to do is PS. We want to kill 94228 PS. Maybe that. Hopefully, let's see how this is behaving. We read bytes. What was the command? 8. 8 killed Bluetooth. And I think now we need to somehow initialize that device. And I'm not quite sure how I want to do that. So I think that logcat was actually pretty helpful. So if we scroll up, we'll see where it tried to open that uart. Oh, maybe that one's not good. uart. Event uart has bytes. Let's start this back up. Now we can look at the logcat of what it looks like when Bluetooth starts up. And in this case, we have... hasn't made that connection yet to the uart. Log. Okay. BT vendor lib set uart baud 115200. So this is, I think, what I want. I want to figure out how it's doing this. Yeah. So this log is very relevant to what we're doing. So here it's opening it up for the first time. This is it announcing the FD, and here's it configuring the baud rates for it. So we just want to set all of this up kind of in the same way, and then we'll take control of this device. So this is BT serial vendor, and we'll just Google that bad boy. Let's scroll off screen. Sorry. So if we look at this, and I want Android Bluetooth stack. Yeah, I think they called it fluoride. Wow, I spelled that pretty bad. Here we go. We'll git clone it locally. cbt code dot. So let's scroll up in my log. I need to find where did that go? Oh, it scrolled off my screen. No. We'll stop this. We'll start it. Logcat. And Control C. Set address. So I think this is what we want. This whole sequence. So I'm going to make a new file. So this, oops. This has like the relevant stuff that we're looking for. So what I want to do is look for this. This is where it opens up the serial port. Really? What? Is that not in this entire code base? What? Where is this code written then? I'm trying to find where this code, libbthci, this log tag here. So then we want to look for vendor open. So this is how they open the serial port. Oh, they use a socket? Maybe that's my problem. Maybe I need to do a socket rather than a directly opening the TTY. That might be the issue. I feel like I would have tried this before. But this is how it's doing it. AF Bluetooth sock raw, BT Protor HCI. This is setting up the filters. Bind a socket to the HCI device. set the socket to raw. And then what else do we have? We have device FD is open. Yep, we see that in the log. Run thread, set baud rate. Let's see where this is at. BT vendor lib, set uart baud. This looks like this is in libbt as well. So this is source userial vendor, BT vendor Broadcom. What's this? Baud, userial config, init, debug tuning mode, opcode. Oh, power control, SEO config, userial open. That's kind of interesting. Userial close, LPM timeout, wake set state. What is this? Power off, power on, set Bluetooth power? Is that the issue? Do I need to power on Bluetooth? Like, how does this device start talking to me? Oh boy. Userial baud rate. Sets new baud rate. Userial BT wake. Asserting BT wake. Is that what I need to do? This is on the userial. What's this? BT wake assert. Uart that wake. How do I wake this up? Userial vendor wake assert. Maybe that's the issue. Set the open state of the BT wake if ioctl is used. Unsupported baud. This is vendor open. Unsupported data bits, unsupported parity bits, TC flush. If wake via this. Device FD, that is open. Userial vendor. So this is vendor open. So this is the print we're seeing. Whoops. What are we seeing? Userial vendor open. This is what we're seeing. It's trying to open dev ttys2. It calls open read write. So we just need to mimic this, I think. I think if we mimic this, I think we're fine. So let me get this all figured out. Welcome to the boring part of reverse engineering. So I open as read write on the TTY device. Then what I want to do is TC flush on FD of TCIO flush. And hopefully those are in libc. And oh, hell yeah. And libc. Okay. Failed to open the file for dumping. Yeah, why is that? Doop. Failed to open file for dumping. slash terminate frame. Okay. I need to kill that Bluetooth device. Let's see. Paste. We're gonna get this to work. I promise. I promise. Couldn't fail to open TTY device, so we want to kill Bluetooth, which is 8 PS. PS grep blue. Okay, Bluetooth is no longer running. If I look at logcat, hopefully we see cleanup called vendor HCI module. Website thread, cleaning up pan interface, cleaning up this. Device FD close. Okay, so it has closed that FD. So that FD is now completely owned by me. Then, let's do this. So that's working. And I'm just gonna do it exactly as they do it. Sadly, it's kind of on the other screen, but we're going to do TC get attribute, which we don't care about. TC flush, TC set attribute. Okay, these might matter. Set input output baud rate. Is CF set? Oh, this is a real thing. Okay. Yeah, but this is good. If I can get this to work cleanly, because I've never had this work clean. So let's do libc tc get attributes fd into v and d. Mute term ios, and that is let mute term ios is equal to libc term ios. I think that's probably the type. Equals so let's see, is that right? Oh yeah, there's no standard. Awesome. What's this doing? Make. Okay, so then we're doing a tc get, and then we do a cf make raw, libs. Awesome. Libc, and I want to do term ios.c cf flag. CF. Oops. This is C under C flag or equals libc crt scts or stop bits, which I think we want stop bits 0. We'll do stop bit 0. Let stop bits equal 0. And then tc libc tc set attributes fdt libc tc sa now term mute term ios, and they don't check any of the return values of these, so I'm not either. Libc tcio flush libc tc set attribute fd libc tc sa now mute term ios libc tc flush fd tc libc tcio flush, and it does this twice, and then libc cf set o speed term ios, and then the baud rate, and then it sets I speed to baud rate, and then t libc tc set attribute on fd libc tcsa now mute terminus. And that's getting close to being ready. Baud is not found. Let's see, baud rate is baud is B115200. I don't know where that comes from. Let me so I'm seeing that it's setting this baud rate. No wonder Bluetooth is so terrible on Linux. Okay, so do we have a .h file with the same name? No, rip. Hardware, let's look for this. Is this, oh, this is an actual thing. Okay. So, serial, open 115200 is like the fallback. I don't think I saw data bits used. New serial vendor open. We opened the serial port. We TC flushed. Oh wait, is this a different one? What is this? TC flush. Then we get the attributes. We do those things, and then at the end, baud. So let equals libc b115200 maybe. Okay. And then there is a bt wake, which is to libc iactl of fd userial wake assert, and then a null. I gotta find where this is. Userial wake assert. I'm trying to find what this ioctl is defined as. I mean, we could try it without it. We could see what happens. We could see if this is right. Nope. Nope. Let's see. Hopefully that wake does it for us. Do we see that serial debug? BT wake. Do we have that in here? Set uart bond 115200. FD open. Okay, what is this? What is this? Where can I find this defined? HCI uart.h. This. These are the iactl values for the BT wake iactl for the uart driver. You may need to redefine them for your platform. Yeah, we'll just do that. 8003. I swear, if this works, if this is the trick, if this fucking works, please, 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 please. Nope. 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 Did you detect the bug earlier? No, we're writing something that allows us to dump out information from a serial port, or we're trying to dump the memory, the RAM and ROM of the Bluetooth chipset. And in this case, we're just struggling to get it to respond to us. And I think I did all of this exactly as they do. TC get attribute, terminos. So we open the serial port, we TC flush, we get terminos, we make raw, we set that and stop bits, we set attributes now, we TC flush, we set attributes now, we flush. We set the O speed and the I speed based on baud. We set the TCS now. And then we do this ioctl thing here. And then at this point, we're done and we've returned up. So then I have to look at other things. BT hardware config. Let's see if this works. BT vendor Linux. Hardware config enabled. That's not what we want. We want BT vendor lib set uart baud. This is the string we're interested in. This. There we go. So this, for controller configuration, status, streamed to that. Ask for a new buffer, big enough for HCI commands. Status is this, stream this. This is the callback. So something is registering this callback. Read beta address. Local CD adder. We see. I'm just looking at kind of the things I'm seeing. Hardware config. I see these. The patch file. Maybe I have to. Let's see where this is. The firmware patch file. Patch file. Find patch. So here, wait, is this a recursive function? Download mini driver. Yeah, we're still live. Why not? We're hacking. Can't stop, won't stop. You know? The hacks never end. What are we doing? Oops. Come on. Close. Exit. Sorry. Let's see. So, honestly, I really need to fix my sleep schedule. So I probably should end the stream. I really hate to say it, but it is 3:15 in the morning, and my sleep schedule is so screwed up. I think I'm gonna go to bed. I'm going to try and get this. I'm going to write this up and get the dumper, the read and write routines to work, and then we'll hop back in Ghidra whenever that's up and running. I don't know when I'm gonna get time. Maybe this weekend, maybe tomorrow, but. I need to go to bed and have a normal sleep schedule, but okay. Yeah, sorry, man. What I was up to is I was using Ghidra to reverse engineer out this Bluetooth chipset, but we just got to a point where it was trying to access memory that we don't have in our memory dump, so I was going back to update my memory dump tool. So, but I'm going to, I'll try and get this working off stream at some point when I find some time, get it more stable. Maybe I'll buy a Nexus device or something. But once I get this polished up and I'm able to just arbitrarily read and write things in bulk, we'll come back and start looking at this stuff again. Could you show how function graphs look like in Ghidra? Sure. They just look like, window function graph. So just like this. So they're not as nice as IDA, I would say, but they're pretty usable. The lines I'm not used to kind of how these work and how to recognize loops and stuff. But anyways, yeah, this is not a Linux driver. This is a userland application running on this MIPS device that connects to the Bluetooth serial port and issues raw HCI commands to it. I kind of piggybacked on Bluetooth initializing the chipset for me, and then I used the serial port, but then Bluetooth, the actual Bluetooth code in Android was using it at the same time that I was using it. So obviously that has a lot of issues. So I need to find out how to actually initialize this serial port and get it to work. So anyways, sadly, I'm going to wrap it up here. I'll be back at some point in the future to do some cool streams. So thank you very much for tuning in. I'll do some new stuff soon. And maybe I'll do something on a weekend where I can get... I know I probably have a lot of European viewers or other people outside the US, but I would like to get a stream during kind of midday on a weekend for US, because I feel like on the West Coast here, I'm missing out on a lot of East Coast people being able to watch. So anyways, thanks for tuning in, and hope you guys enjoyed.